So 4 networks. To get 4 networks, how many host bits do we borrow? 2, isn't it? 2 raised to power 2 will give us 4. What if the question was to get 5 networks? How many do we borrow? 3. 3 will give us how many new networks? 8, right? Someone will ask, why not borrow 2? Would 2 give you 5 networks? No. Okay. So that means for the question 2, we have 2 raised to power what? 2. That will give us how many new networks? 4. So that means we're moving from a slash 24 to a slash what? 26. Do we follow? By the time we convert a 32-bit value that has the first 26 bits on, what value are we going to get in decimal? A 255.255.255 dot something. You can calculate that dot something, right? You find it. The first 2 bits are what? On, right? Isn't it? We all agree, right? Uh-huh. So if the first 2 bits are on, remember the value of the first bit. 1 what? So 128 plus second one, 64. So that gives us what? 192. So that means our subnet max is 255.255.255.192. So that means our block size will be 256 minus 192, right? What would be the answer to that? What would be the answer to that? $64. Very correct. So that means our network is increasing in how many bits? Afterwards, 64 devices, we'll get a new network. After another 64 devices, we'll get a new network, isn't it? So if the first one is 5.0, that means the second network will be 5.64, isn't it? If the second one is 5.64, the third one will be 192.168.5.0.64 plus 64, 128/25/26. Sorry. In this case, we are dealing with a /26 network. Then the last one will be what? 192.168.5.128 plus 64. 22 what? There's not 225 now. It's 192. Right? 128 plus 64. Confirm it now. One. Okay. /20 what? Very correct. So those are the 4 new networks. The answer should be looking in something like this, isn't it? Very easy question. What about the next one? What's the next question? You have a question from this? I'm shocked too. Okay, ask your question. The question says, what's the first thing in the question? 4 subnets. So first of all, the question has told you what to do, isn't it? It needs you to divide that modern network into how many new networks? 4. Then in that 4 network, they are saying now that in that 4 network, they'll be using only 25 hosts inside it. So don't be confused. The network we have created can contain how many hosts? And they said out of that 64, they are willing to use only what? 25. The first one that we created, that's the first question, 2 subnets with how many hosts inside it? But actually, how many hosts can be inside that first network? 128 minus 2, isn't it? 120 what? 6. So will you say because of that now, it's too big for them, you'll go and reduce it? No, now. The question just is simple. First thing there, the keyword there is what? 2 subnets. You already know what to do. Next keyword there is what? 4 subnets. You already know what to do. So
Sorry, now following her question, total number of IPs we need for that 55 is 27. That's the minimum.
no, that's what you are missing. Read the question where? The question said, okay, can we go off subnetting first for a minute? Can we go off subnetting first? Yes. All right. You have one plot of land, right? That has a size of 100 by 50. Are we good with that? Yes. Now, it says, can you divide that plot of land for 2 persons? That's the first question, isn't it? 2 subnets. 2 what? Persons. What do you do? I'm asking us, what do you do? Eh? You divide the land into what? That's all. You are not, it's not your business if Mr. A wants to only build kitchen. It's not your concern if Mr. B wants to build bungalow. Do you understand? Is it making sense now? The first thing is what? Divide this network into how many parts? 2. But they're not telling you, okay, just to confuse you now, to know how much you can actually answer the question. If they are only using 25 of it, it's not your business whether they refuse to use this other part, isn't it? Your own part is done. You have done what? The division. That's just the question. So the next question that they say, divide into how many parts? 4. What do? You have it again. To fit how many persons? 4 persons. It's not your concern if this one build in a small portion of that land you gave to him, isn't it? That's the question. So don't be confused. If the question didn't tell you the number of subnets that was needed, then it now told you the hosts that are needed. Then now, what do we not care for? We not care about slim fitting the network we are forming to fit what? The host. So based on this now, I think we can know which one is more important. Which one is more important? Which one is more important? The subnet. The subnet is what? More important. It takes more precedence. So if you see a question that tells you, I need 2 subnets, it's not your business if they only want to use the 2 IPs inside it. The precedence is what? The number of new networks that is what? Needed. But in the case where you're not being informed that I need this number of new networks, I need a network that can contain this number of hosts. In that case now, you now consider the size of the host, isn't it? You now need to slim fit it to the network you're going to break it into. You have to make sure that it matches the number of hosts that are needed in that network. Does it make sense now? Ma, is your question answered? Okay. The second question, it says we are given an IP address. I'm not going to use the IP on the question, but we're going to solve it with another different IP. You want to copy? Who posted that in their group? Eh? So we want to understand more by copying someone else's answer. If I ask you a question and I solve it for you, is that good? Is that good? Okay, I have an IP address 154.0.99. 100/27. And I'm saying, given this IP, can you derive the network address, the broadcast address, and the host range? Can we derive it? There's a slide that talks about this, isn't it? When you're given an IP address, how to derive every detail from what? That given IP, isn't it? So first of all, we know that this is the unique IP, right? And this is the subnet that IP belongs to. You all understand that, isn't it? Okay, so the first thing to do, what's the first thing to do? You can convert the serial number into the subnet mask, right? Which will give us a/27. It means that the first 3 bits in the last octet are what? On. Do you understand that? Then the remaining 5, right? The remaining 5 bits are off. By the time we convert that number, 128 plus 64 plus 32, it gives us what? 224. Isn't it? Isn't it? Okay. So based on that, you already know the formula for block size, right? What's the formula for block size? What's the formula for block size? Okay, so 256 minus the last subnet in our case, which is what? 224. What's the value to that? What's the value? 32, right? So it simply means that a/27 network will always be having how many bits inside it? How many different hosts inside it? 32. So it's increasing in what? In bits of what? 32. So that means we can start from the beginning. The beginning will be 154.0.99.0/27, isn't it? That means the next network will be .99.32, isn't it? So the secret is to find out where this one, which network this 100 would be. So the next one, .32 plus 32 will be how many? After that one, 96/27. After that one, 128/27. I think we've passed where that IP address is, isn't it? So, okay, now I ask the question. The IP you have on the board, which network is it in?
Between 96 and 128.
Is in between 96 and 128.
128.
Based on what you have here, this given IP address, which network does it belong to? I asked you that question. The third subnet. Call it now, call it.
It's at that range.
It's at the range.
At the range of 96/128/27. 96/128.
It simply means that this IP address, right, belongs to which network? It belongs to only that network. Only. It cannot belong to 2 different networks. Isn't it? It's only in this classroom. It cannot be in 2 different classes at the same time. Are we following? So that means our IP, the network, what we call the network address. Remember, the network address is the name of the network. It's equal to 154.0.99.96/27. Based on that now, we now know that the broadcast, which will be the last IP, right, is equal to the IP before the next network, isn't it? So it will now be 154 192.0.99.9 dot what? 127/27, showing that it's part of that network. So that means the usable host would be between .97 to what? .126, which answers the question for the what? Host range. The broadcast, the network. Simple information you derive from an IP and the what? The subnet ID. It now goes back to the definition of the IP address. An IP address would show you the information of what? The host. That's the host identification. And also what? The network identification. Isn't it? These are simple drills that ask us based on what we have already learned in the class. So if you follow through in the classroom, you should be able to do this. Is it clear now? Is it clear now? Is it clear now? No, sir. Where are you confused? Ask now. You said no, sir. Sir, stand up, please. Ask us. Ask the class. Where are you confused?
Okay. Sorry, just that, the formula, I'm not too conversant with this book.
Okay. You're not conversant with the formula. Have you, as you went back home, did you look at the slide? Who else? If you go back home, look at the slide. As we are learning, write things down. How many formulas did I mention in the class? They are just under 5 formulas I mentioned. They are not easy. They are not hard. Block size is equal to 256 minus the last what? Subnet. You can always identify that. The number of new subnets that will form after your borrowed host bit is 2 raised to power the number of host bits that you have what? Borrowed, isn't it? Yes. Then the size of the host in the network is equal to 2 raised to power the host bits minus what? 2. Just simple formulas. If you go back, you can read them. You can cram it. You can solve more what? Questions. There are questions online. In fact, you can tailor your Google search. Show me subnetting questions from CCNA exams. Show me subnetting questions in networking. And you get different questions. And you begin to what? Solve it. It's good that before I answer your question, someone will say, what if I don't know how to solve it? What if my brain cannot carry it? There are online calculators that you can actually use to what? Subnet. But in an exam hall, if you are writing an exam, because at the end of the day, in networking, what tells the world that you are certified is when you take an exam, isn't it? Yes. Isn't it? Yes. We all agree with that. Yes. And in writing an exam, in fact, inside Speedlink here, there's an exam room where they write exam. And if you want to write your Cisco exam now, we have a place where you write it inside our office here. Now, if you come to that place, as you're going into that exam hall, the only thing you're allowed to go into with the exam hall is a blank paper and a pen. Only. No calculator. So, as I'm teaching you networking now, and you're hoping that in the future, you will write the networking exam, you should prepare yourself that there's no calculator when you're going to write a networking exam. So, what we are doing now, is it useful or not? There are online calculators, but I don't want to teach you online calculator because it's a waste of time. At the end of the day, I'll just teach you and you don't know what's up. You don't know what's involved. You are configuring an AWS instance and they give you an IP block and you can't even identify if the IP is public or private. And you start trying to connect to that computer from your own local computer. How would it work? Are we following? We thought it twice before involving every one of us from all our tracks. Fiber, AWS, cloud network, and what? Cyber security. All of us, in one way or the other, we're going to be working with what? An IP address. So please, go home, practice it. We don't have time to be wasting our time here and be solving different questions. We don't have time for that. Some of us will just be in this class for 1 month. Do you want to derive the best before you leave? So please, when you go back home, try and work on your what? On yourself. Solve questions. I can't teach you everything. I'll show you what? The way. If you don't understand, ask question and I will explain. Can we move forward? The last question, which I said would be difficult, isn't it? Did anybody solve it? Did you get the answer? All right. We'll know if you got the answer now. For that question, I'll solve it here on the board, that particular question. Okay? And for that reason, all of us will be graded the same thing. It's just, we'll all be graded an equal mark. So don't be scared any longer. You are given an IP address of what? 172.16.0.0/16. And they said subnet it to support first. How many hosts? 300 hosts. Then next, how many hosts again? 100 hosts. Then next, 50. It's 50 or not 60. Then next, 20. Now in this case, the subnet, they didn't tell you the number of new networks needed, isn't it? So that means we're only going to deal with the number of hosts needed. Do we follow? All right, based on that, if we need 300 hosts, how many host bits should be in that kind of network? We need a network that can support 300 devices. How many host bits should be in that kind of network? 9. So that means 2 raised to power what? 9. That will give us how many? Okay? If we need a network that should support 100 hosts, that will give us how many? How many host bits? 2 raised to power 7, which will be what? Okay. What of a network that should support 50 hosts? How many?
64.
Okay. Then lastly, a network that should support 20 devices. 2 raised to power 5. Okay. Now, a critical step that we should all remember. Where do we start from? The largest, not the smallest. Not randomly. The what? The largest. So we have to subnet this big network to first of all fit the what? The largest. Then from the spare, we can now subnet and get the what? The rest. Do we understand? Okay. So we'll start with the largest, 2 raised to power 9, isn't it? Yes. 2 raised to power 9 hosts. That means, it means that out of 32 bits, 9 of it are for the what? Host, isn't it? So that means, how many is left for the network side? 23. So that means we are forming a network that is a what? A /23. We are breaking a /16 to become a what? A /23. Okay, based on that now, so let's proceed. A /23, the subnet max, what will it look like? 255, right? Dot 255 dot. Because it's 23, now that means the subnet max is inside the third octet, isn't it? Isn't it? So that means we have a 255 and a 255. Then out of the 8 bits here, 7 of them are what? On. 370. By the time we convert this number, we'll have what? 254. Isn't it? Then this other one will be what? 0. Because all the host bits they are off already. So it's a 0. So that means our subnet max is 255.255.254.0. So based on that, what would our block size be? Our block size is equal to 256 minus what? 4. Which means how many? 2. Okay. So what's the next step? We know our block size. We know our block size. What else don't we know? I believe we know everything already now. We know everything we need, isn't it? So it's to write down the new networks now. Okay. So the first network obviously is 172.16.0.0/6 slash what? 23. Okay. So what will be the next network?
172.172.0/23.
Who does not agree with that? If you don't agree, please raise your hand. Can we tell him why we all agree with that answer? What's the reason for the 2 being in this octet instead of this other octet? All the ones who have been doing since, we are always adding in the last octet, isn't it? Now we are adding in the third octet. So what's the reason?
It's because this other octet is already 254, and it can hold only 255. So we need to move to the next one.
Okay. There's a way I put it. You can see that, sir. There's a way I put it in the slide. I say the block size is equal to what? The subnet where we have the last what? Network bit, isn't it? Something that looks like that. The subnet, the octet that holds where the last network bit is and where the host bit begins, isn't it? In our case, is this what? Third octet. Because in the third octet, we have 1111111 with what? A 0. That 0 shows the beginning of the what? The host bit, isn't it? So that means anything we are doing would be in that what? Octet, where the network and the host bits are what? Together. Do we get it? Where that host bit starts. The host bit is starting from this third octet. So we are going to be working on what? The third octet. Does that make sense? Okay. Ask again.
From what we got from our host range, it's 2.
Yes.
So if we start counting from .0.255, that we have gotten 255, and then .1.255 should get us that 512 that we are looking for. So what I don't understand is why it's .2 instead of .1 in the third octet.
We are adding what? The block size, isn't it? We have been adding that, right? When we want to find the new network, what do we add? The what? The block size. So I don't think we should be adding 1 when the block size is telling us we should add what? 2. That's what I just think.
But when we do the range now, it will be more than 512.
Hold on. When we do the range, you will see it. It will not be more than. What's the next network? All right. So I believe we'll have a lot of networks until we get the last network, which will be 172.16.254 0.0/23. Why do I think so? I think so because you remember we started from a /16, isn't it? Which means we had 16 host bits. We all agree with that, isn't it? Now, to arrive at the /23, how many host bits did we borrow? We borrowed what? 7. So that means the number of new subnets that will be formed is equal to 2 raised to the power what? 7. That gives us 128. So we'll be having 128 new networks. And if I'm going up in a series of 2, and I have a lot until 255, that means my last network should be like half of it, isn't it? Half of it gives me 128. So we're around that value. Another way that I know that this is the last network is that if I add the next 2, what's the value I get? 256. And we don't have a 256, isn't it? A 256 means we are adding a 1 to the next octet. Do you all agree with that? Now, by the time I add a 1 to this octet, that makes it a what? Is .17. And if you look at the beginning, .17 is not involved because a /16 tells you that you're only going to be changing this octet and this what? Octet. 8 plus 8, 16. You're done. If it was a /15, which means that we'll be having something, a host bit inside this octet, that means we should also have a chance to work on that what? Octet. So based on that, I just know that this is the ending. It's as you begin to solve more that you know, you can easily identify them. But if you want to list them out, the 128 new networks, you will end up at what? This one. Are we following? You can count the series. You can count it by yourself. 0, 1, 2, 1, 2, 2, 4, 3. And you go. By the time you get to 254, you have counted up to what? 1, what? 2, 8. Does that make sense? Then we can now pick out this first one and allocate to who? The network that needs 300 hosts. Isn't it the way we're doing it? So we can now say 172.16.0.0/23 is for them. Okay, to answer your question about the host range. Now, I'll pick out the first one. Let's look at it with the first one. The first network is 172.16.0.0/23. /23 is not 24. Now you're giving out this IP address, and they say derive all the informations that you can from it, which would involve the network address, isn't it? The broadcast address and the host range, isn't it? They say derive everything you want to derive from it. Now, because it's a /23, okay, we have already written the subnet max, isn't it? That's the first thing we normally do. We convert the /23 to what? The subnet max, and we've done that already. Then based on that, we find out the what? The block size, isn't it? After finding out the block size, what do we do with the block size? We use the block size to know the next network, where the next network will be, isn't it? Isn't it? Okay, so based on that, we've gotten that the first network is 172.16.0.0, which is in this case the same IP address that we have there. Do you all agree with that? So I can write down that the network address is equal to 172.16.0.0. Right? The broadcast address is the address before the next what? Network. Isn't it? That's how we've been doing it since. So please, can someone tell us what's the IP address just before this one? The IP address sequentially just before this other network. What's that IP?
172.
The one dot what? That's the wrong.
255.
Dot one dot what? 255. Let's write it down somewhere. Okay, that's correct though, but let me write it down. The 1.255. Now, why did I say sequentially? If you add 1, that's the next IP address after this one. It gives you 172.16.1.256. But we know that 256 is not a valid IP. So it means that will change this octet to what? A 0. And we're going to add that one to the next octet, which will now become 2. Are we now arriving at that new network? So do you now see why the broadcast address is 172.16.1, an octet before it, 1.255? Does that make sense? Okay. So that means the host range now will be from 172.16.0.0.1 up till we get to 1.254. So that means 0.255, 172.16.0.255. Is it a valid IP address? Is it a valid host IP address?
Not a valid host
Is this IP address a valid host IP address?
No.
How many no's? No's indicate. No's indicate, now be proud. Okay? Yes, indicate. All right? Okay, now let's look at it critically. If it's not a valid IP address, what is it then? Is it a broadcast? This IP and this IP, are they the same thing?
No.
So who is it broadcasting for? Which network is it broadcasting for? Because obviously it's part of this our network. We cannot have two broadcast IP addresses, isn't it? Just two. One for the network and one for the broadcast. Those are the two that we are removing. So if we can't have more than two, we are removing. So why do we not have two broadcasts inside one subnet? It's not possible, right? So it means, obviously, in this network, this 0.255 is a valid host IP. But if it was a /24 network, because that will be the last IP address in that network, it's not the broadcast of a what? A /24 IP. It's confusing, but if you understand it, it will not confuse you. Do you understand? You know the range. You cannot have a broadcast in the middle. The broadcast must be what? In the ending. The network must be in the what? In the beginning. This IP address is part of the middle side. Because after 0.255, we'll now have 1.0, which is also a valid host IP. It's not a network address. Are we understanding? We'll get this. All this is part of this range that we have mentioned here. That's why you need to understand how to fetch the informations of an IP address from both the IP and the what? The subnet. The subnet is very important. Without the subnet, we cannot achieve this. Do we follow? If we don't have the subnet, we cannot what? Achieve this. We just know there is an IP address. But when you begin to find out who is the network and who is the broadcast and what are the valid host ranges, you must now start looking at what? The subnet. Does it make sense? Okay, based on this now, if you got it, can you indicate? All right. You did well. Are you proud? So let's quickly dive into what we have for today. What's our topic for today? Switching, virtual LANs, which are layer 2 technologies. We've looked at them before. I said a switch is like what? An extension, isn't it? It's a switch is like a what? An extension, isn't it? Having multiple ports. As part of the lab, I think we'll have a hold of that. So that we'll work with it. And it means that anything you plug in here, any network that comes in inside one of the ports will be the same thing going out of the other ports, isn't it? Just the way your normal electrical switch works. If you plug an extension to your generator, it means that all these other ports will be having power from the what? From the generator. Does that make sense? Yes. All right. Then, as part of the class today, we'll go into what we now call virtual LANs. In networking, anytime we refer to the word LAN, you know that, first of all, what does it mean? Local area network. But we use that word LAN to denote a network, just a single word, network. So anytime you're saying LAN, let it not confuse you. It just means what? A network, a single word, network. So the normal operations of a switch is that you plug in something here, every other thing would belong to what? That network, isn't it? That's the normal operation. You plug in your extension, every other thing connected to it would have what? Power from the same source, the same network. They're all part of the same network. But when we go over to the keyword or the topic we call virtual LAN, it now talks about how we now further divide switch to carry two different networks, two or more different what? Networks. It's virtual. Remember that word, what? Virtual. It's not physical. You're not doing the splitting physically. You're doing it inside what? The switch with maybe some configuration changes. Do you understand? So it now means that we can put these ports here as part of one network. We can now put these other networks, these ports here, as part of what? Another network. Then these remaining ports here, we can also put them as part of what? Another network. Does that make sense? So it means all the cables coming from our classroom, we can plug it inside here, right? Then that means that anything we are discussing in this place, all of us will be hearing it, isn't it? Because we are using the same broadcast address, or what we call collision domain, right? So that means the people in this other side, anything they are discussing, they are sharing the same word, broadcast domain. Does that make sense? Did I say collision domain? Sorry, I meant broadcast domain. Broadcast what? Domain. So everything here is in the same broadcast domain. Everything inside this other switch, this other virtual LAN that we have created is a what? In a single broadcast domain. So all the ports here can eavesdrop on what is happening, isn't it? Then when we come to this other one, everything here is also a single what? Broadcast what? Domain. So in essence, it means that we have divided this switch into how many new networks? To carry what? 3 new networks, this side, and what? This side. Does it make sense? You can use the switch with the default configuration that makes all the ports in the switch as one single broadcast domain. Or you can use VLAN to divide a switch into different or multiple broadcast domain. Does that make sense? We'll find out why we talk about VLAN as we proceed in the class today. Okay, I started the slide today with DHCP. We've been hearing about it. I think we're done with IP address, isn't it? We are done with IP address. We understand what an IP is. We understand what subnetting is. So we now should start talking about the things we use IP address to do in the network. So the first one is, how do we configure an IP address in your computer or in a host computer or in a router or in a switch or in a printer? Anything that uses networking interface, how do you configure an IP address in it? The first is 2 ways, right? One is what? Dynamic. Why the other one is what? Static. Do we all agree with that? One is what? Dynamic. You don't need to manually go and set it. When you connect to a network, the network is responsible for providing you the IP address you will use. Why the other one is static? You have to be responsible for imputing the IP address. So, what's the meaning of DHCP? Okay. It's responsible for assigning IP addresses what? Automatically, isn't it? It is used in networks with many devices. And the IP addresses can what? Change over time. For instance, if you've been coming to Speedlink and you've been looking at your IP address, you will notice that every new day you come around, you're using a new, different IP address. Does that make sense? If you've noticed it, if you looked at your phone, your computer, you will notice it. Every time you come, you're using a new IP. What happens is that the DHCP, when they are configuring it, or when an administrator is configuring it, is a pool of IP or a range. Let's say it's a /24 network, where .0 is the network address, right? And .255 is the what? Broadcast, isn't it? So that means the host inside the network is from .1, right? To what? .254. You should be getting used to a /24 network. That's the simplest. So the network administrator can say, okay, I want to be assigning from .10 to .100 from what? DHCP. So anytime you come to the network, you're going to be given an IP from what? This what? Pool. What we call an IP pool. You go and lease IP from it. It assigns it to you. After some time, if you are off the network, it retrieves it back. Does it make sense? So in networking, we call it DHCP lease. You're leasing an IP address. Okay, I want to join your network. Can you assign me an IP address that I will use while I'm part of your network? The DHCP gives you an IP address. When you're done using it, you have gone out from the network. You are offline. The DHCP will what? Retrieve it back. If another person comes, it can issue out that same IP address it gave to you previously to the new person. Does it make sense? So you now see why your IP address can be what? Can be rotating. It's not what? Permanent. When your computer requests an IP from a DHCP server, the DHCP server is responsible for returning the IP address, the subnet mask, what we call the default gateway, and what we call what? The DNS server. We've not talked about, in this class, we've not talked about the default gateway, isn't it? Default gateway. And we have not also talked about what? DNS. So those are key topics that we should look at today. So pay attention to the class. But before we head to that place, I'll just explain what's the work of a router. It interconnects two different networks. It enables communication between two different networks. All right. Another name for the default gateway is what? Router. That's what it just means. So in your computer, when you're setting an IP address and you see a space for default gateway, it's just asking you, please, as you're putting this IP address, what's the IP address of the router that will route your packets from this your network to other what? Network. That's what the default gateway what means. Do we understand? All right. So let's proceed. The advantages of DHCP. The advantages of DHCP is that it is what? It aids in centralized what? Management. Because as the network admin, I can configure that all my IP addresses that will be leasing out will be coming out from what? Only what? This pool. Have I managed the IP address centrally? Yes, I've done that. It enables easy scalability. For instance, if the network was to grow, let's say we are using a /24 address, which enables how many hosts? 254 hosts, right? Now, if we have grown more than 254 devices, for instance, before we came to Speedlink for the program, maybe Speedlink just had 50 employees around, and maybe 50 smart devices. That means the network, the IP addresses that will be used in the network is equal to how many? 100, isn't it? 50 for the employees in the company and 50 for the smart devices in the company also, isn't it? Now, we have come to Speedlink and we are also using Speedlink network, and our number can be more than what? 200. Do you understand? So that means Speedlink network now has grown from being a network that should cater for 100 devices to a network that should now cater for 300 devices. Do you understand? Are we seeing the scenario I'm painting? Now, if you manually set the IP addresses in each of the computers, when there were 100 devices, they will be using a /25, isn't it? Isn't it? Where the broadcast will be .127, right? If you check it, you see the broadcast will be .127, or the last one, .255. Now, when the network now has grown from being for 100 devices to for 300 devices, it means now that we need a /20 That means the broadcast address would what? Change, obviously, right? It now becomes something like 1.255, just like we found out today in the class, right? Now, having seen this now, it means now that in those 100 devices that you have configured manual IP address for before, you now need to what? Edit them. Would it be a painful job? Opening 100 computers, you first of all edit them and tell them that, okay, no, we are no longer using .127 for broadcast. We are now using the 1.255 for broadcast. It will be a painful what? Job. So what do? We utilize what? DHCP. With a simple configuration on the router or the DHCP server, as you issue that, okay, no, I'm no longer using this pool for my DHCP. I've increased it from, instead of instead of 0.10 to 0.100, I'm now using 0.10 to 1.100. I should be able to fetch out 300 IP addresses from what? This range, and support the people that will now join the network. Do you now see that as you come to the network, instead of the DHCP giving you from the former pool, it will now be giving you now from what? This new pool. So that means for the 300 devices that will come to the network, we have effected the change globally. Isn't it? Isn't it? Is that one better? Is that one better? Yeah, so that is why we use what? DHCP. It enables central management. It enables us to scale the network easily. And it also enables what? Misconfiguration. For instance, if you are to be changing the IP address, the subnet mask, and the uh, broadcast address for the following 100 computers, you may slip out in one of them and you make a mistake, isn't it? And that the person using that computer will be complaining. It's not working. It's not working. You find out that it's because of what? Misconfiguration. DHCP helps us what? To avoid this. I think based on that, I've already talked about what? Static IP address. But there are times when we have to use what? Static IP. DHCP is good, yes. But there are times we should use what? Static IP. When do we use it? For what? Servers. What we call what? Servers. For some printers, for routers, for switches, or any critical infrastructure that needs what? What we call consistent what? Address. For instance, the IP address of google.com, or you're hosting a computer, you're hosting a web server locally. The IP address is 192.168.1.1. Those of us that use MiFi, 192.168.1.1, isn't it? Isn't it? Now, if that IP was always changing, would it be fair? Would it be fair? It will not be fair. Because every time you want to access the MiFi login screen, you go and start finding out the new IP address. It will not be what? Fair. So in that case, we always make use of what? Make use of static what? IP address. Because we don't want those kind of IPs to what? Change. I believe we understand that by now. Okay, there's another keyword again for default route. Default what? Gateway. They all mean the same thing. Default route, default gateway. It means the IP address of the what? The router. Then we go over to DNS. What's the meaning of DNS? The domain name system is what we call the phone book of the what? Of the internet. It resolves what we call the domain names, like google.com, to an IP what? Address. What this means is that you go on your computer now, you open up the web browser and you say facebook.com. Is facebook.com an IP address? No, isn't it? And based on our foundation classes, we know that any communication in a network is enabled via the IP address. So there's nothing like facebook.com in the network. There's nothing like facebook.com in the what? In the network. It's not an IP address. So you cannot directly communicate with it. So what happens is that the DNS would resolve that domain name to what? The IP address. It's just like saying in your phones now, we all have our mobile phones, isn't it? You have your parents' number, your dad, your mom, your siblings inside it, isn't it? We all do that now. Yeah. Or we have our friends and colleagues' phone number. Now, just imagine that inside that phone book, anytime you want to call your sister, you start dialing her phone number. Would that be easy? Or you are the chairman of Obagi, and every time you want to call someone in the class, your student, you start dialing the student's phone number. Would that be fair? No, isn't it? What do? You save the person's phone number with a what? A name. That's the same thing the DNS does. It knows the IP address of google.com. That's the phone number of google.com, right? Now, it saves that IP address with a what we call a domain name. So that anytime you type in your phone, google.com, in essence, you're dialing the IP address of what? google.com. Does that make sense? Yes, so that's the way the internet works. The first thing is that when you open your web browser and type the domain name, www.example.com, the request is first of all in the background without you knowing. It is sent to what? The configured DNS what? Server on your computer or your phone. That DNS server would reply with the corresponding IP address of that domain name that you want to what? Visit. And your computer will now send the request to that actual what? IP address. Does it make sense now? So anytime you are typing google.com, I believe now you know that google.com is not what? An IP address. There's a domain name that should what? Do that. So based on this now, there are some challenges that could form in the network where users are able to communicate using IP address. But when they try to visit a domain name, it's not working. At that point in time, what's the problem? We have not configured a DNS what? Server. Or there may even be a what? A misconfiguration. We have configured it, but we didn't configure it what? Well. Do you understand? So, with that now, we are learning how to what? Troubleshoot internet what? Issues. Okay? The next slide today. Okay, we have types of DNS records. We have the one we call the A record. This is just for your digestion. You can take them in. The DNS A record is what maps a domain name like google.com to an IPv4 address. Some of us who may go into details and we'll start looking at these things in more detail. We have the quadruple A record, which is the one that maps the domain name to what? An IPv6 address. Remember, we have IPv4 and IPv what? 6. Then we have the DNS MX record that maps the IP address of the mail exchange server. We have the CNAME, which is an alias to another what? Domain name. When you want to map a domain to another new what? Domain. Somebody is coming to visit mail.com. You want to forward that request to google.com. You use the CNAME. We have the PTR record, which helps in what we call reverse what? DNS. When you reverse DNS, we use that when we issue out, want to do reverse engineering. I know your IP address, but I don't know your domain name. How do I find out what your domain name is? It's the PTR record that would help in that. So in the PTR record, it will hold the IP address mapping towards the domain name. So somebody can use an IP address and find out the domain name that are mapped towards that IP address. Cybersecurity, you'll be using that word a lot for your testing. Okay. Okay, so we have the last, I think this should be the last slide on DNS. Yes. We have the last slide that talks about some simple command line tools that we use for DNS. So in your Windows computer, if you're with your computer, can you open them up? Open your computer up. In your Linux machine, you use the command dig. For Cisco routers, we use the command ping domainname.com. For Microtik routers, we use the command ping domainname.com. So in your computer now, open your command prompt. When you open your command prompt, type this command, nslookup. It means name server lookup. Then you type the domain name you want to look up. It's a way of checking that the domain name is what? DNS is what? Working. Do you understand? So, for example, you can type nslookup google.com. So I'll do it on this computer here. For those of us without our computers, let's pay attention to the screen. Yes? Sorry. Font. I believe we can see better now. Can we? So ns lookup google.com. Okay? The reply is what? Domain name request timed what? Out. The server is what? Unknown. Address 192.168.10.25. So then we have the non-authoritative answer, which replied google.com and the address. This and this and this and this and this. This for the IPv6 address, isn't it? And this for the IPv4 address. Now, two things happen in this reply. Is this a local IP address or a private IP? It's a private IP, right? Isn't it? Starts with 192.168. Private IP. Is this public or private? All right. We've not talked about IPv6, so I don't want to even ask you. So what this means is that in this, our network, in the network that this computer is currently connected to, the DNS server was set as a what? A local DNS what? Server. So when we sent this request to look up who is google.com, in that DNS server, it replied that it didn't what? No. Right? DNS request was timed out. It didn't know. But what happens in DNS is that DNS uses what? Recursion. What we call recursion. Because I don't know does not mean I will not give you a reply. I'm going to ask my brother that knows. We know this now. It happens always in Aba.
Yes.
Isn't it? You go and buy something. If they don't have it in that shop, they'll not leave you to go, right?
Yes.
They tell you, hold on, let me go and bring it from my what?
Warehouse.
Store or my warehouse. As they go, they are going to meet their brother that have it. They will ask the brother the price, right? And maybe even mock it up and give it to what? To you. Same thing happens in the network. The DNS server, our current configured DNS server is 192.168.10.25. We are looking up google.com. It didn't know the IP address of google.com, so it didn't reply. But it knows the IP address of the brother what? DNS server. So what happened is that it just sent a recursive request to the next DNS server in the chain. And that one replied because that one knows the IP address of google.com. Then this guy, this first DNS server now brought it back to us. Do you see the recursion there now? Do you see the recursion? This is your computer. This is the first DNS server. And this is another DNS server. You send a request. It doesn't know. It recursively sends that your request to the next what? DNS server. If that one knows, that one what? Would reply it. Right? Then in essence now, it's not going to now reply you as if it knew. Do you see the ABA relationship we're talking about now?
Yes, sir.
So that's the way what DNS server works. What if at the end of the day there was no reply at all? I'm asking us now.
Request again.
You request again?
Yes.
All right. There are several issues that can come up why a DNS server won't what? Reply. For instance, in this case, this one doesn't know, isn't it? What if this guy was not recursively searching for the next DNS server? It means that at the end of the day, we are not going to get a response, isn't it? Or it may be configured correctly, but there may be no internet what? Connectivity. Don't forget about the connectivity. There must be what? Connection for requests to go through and come back. So connectivity can also be a what? A problem. So how do we confirm that there is actually internet connectivity? The easiest way is to ping a global IP address that we know, which is what? Google DNS 8.8.8.8. Do we know that? Isn't it? Which command do we use to test connectivity? Ping. So for the case where it didn't respond well, we can now say, okay, let's ping a global IP that we know. Okay. All right. So do we see a reply there? So it means that there's actually internet what? Connectivity. In the case where there is no internet connectivity, the DNS query might what? Fail because there's no connectivity, isn't it? Aha. So I believe with this, DNS has come. Do you understand what DNS is now? Any question? Any question? If I ask you what is the flow of a DNS request, do you understand that? Can you answer that question? A DNS request. What's the workflow for a DNS request? Can we answer that? Okay. Along the line, most of us will be working with microtic devices. Some of us will work with Cisco what? Devices. In Cisco device, we use the ping command to check for what? DNS what? Query. Because when you try and ping a domain name, what will happen is that the router will send the DNS request first, right? Then the DNS will respond with the IP address of what? Of the domain name, isn't it? And in essence, the ping now that you have sent will now start going out to the what? To the IP address. So in that case, you already know that the DNS has worked. Do you understand? In microtic device or microtic routers, same thing. You send a ping to a domain name. You see that the ping will go and come and start pinging an IP address, right? At that point where instead of pinging a domain name, it's now pinging an IP address. You now know that the DNS query has what? Resolved that domain name to what? An IP address. It's as simple as that. Okay. So I introduced the class today with what? Switching, right? And what? VLAN. Now we now talk about it in detail. We said, over here I put a picture. We talked about the OSI model, isn't it? Last week, isn't it? How many layers? Who can remember the acronym? Please do not throw sausage, pizza, what? Away. Layer 1 is the physical layer. The layer 2 is the data link layer. Layer 4, transport what? Layer. Layer 5, session. Layer 6, presentation and what? Application. Okay? And we said that a switch is part of the what? The layer what? 2. Isn't it? Isn't it? Yes. We said it last week. A switch is in the what? In the layer 2 of the OSI model. And the name of the data that pass through the layer 2, we call it what? Frame. In layer 1, in the physical layer, when data are passing through it, we call it what? Bits. In layer 2, we call it what? Frame. When we head over to layer 3, we call them what? Packets. So in the class today, we are dealing with what? Frames. Do you understand? All right. So switches operate at what? Layer 2. In order for them to do that, they use what we call what? The MAC address to forward Ethernet what? Frames. Now, the MAC address is a 48-bit identifier looking something like this. Can you see it? Obviously, this tells us is in what? Base what? 16, isn't it? It's in base 16, right? It has from 0 to 9, and also from A to what? E. So it means it's in what? Base 16. Just a simple illustration of a MAC address. It has two parts also. This is the first part. The first 3 as the first 24 bits. We call that the OUI. While the last 3 will not be what? Unique. Identifier for that device. The OUI simply represents the ID of the manufacturer, while the last 24 bits will now show you the actual unique identifier for that what? Device. So what that means is that same way we have the network address and IP address, where all the IP addresses that belong to that network would have the same network address, isn't it? So all the devices that will be produced by a particular company would be having the same OU what? I. Do you understand? That denotes who is the maker of that device. Why this other part would be like the serial number that is not unique to what? The device they have made. Does that make sense? When you begin to walk around, you start finding them out. You see that some devices in the network, they'll all be having the first 6 digits equal. Once you see that, you already know that they are the same words. They are coming from the same manufacturer. In fact, if you go and buy, you make a bulk purchase. For instance, you need, let me say, I don't want to call it a laptop because sometimes we don't even buy, we hardly buy new laptop. You buy a switch, an access point. For instance, you buy an access point like this. You buy 20 pieces. And all of them are the same brand and the same type. In the MAC address, you will notice that they will all be having the same first digits, which will denote that they are all coming from what? The same what? Manufacturer. It's just as simple as that. So I just want us to look at this picture, know what a MAC address should what? Look like. What is it going to look like? It's a 48-bit number, isn't it? And it's written down in what? Hex, in 16 bits. So each of these number now is base 16, base 16, base 16. Where the first 24 would denote what? the OUI, the manufacturer. And the last one will now denote the unique MAC address. So if you're with your computers, you can open them up. I don't want to open up the one in this computer because it's a serial number. You don't need to share it, right? You don't share your MAC address. It's very important. You don't share it. It's a serial number. Don't share it to the world. But you can find it. Go to control panel. If you go to control panel, open up your networks, just like you wanted to configure an IP address in your computer. If you right-click on the networks, you will see status. You can open it up. That should show you where you have your MAC address. Or if you're using Windows 10, those of us that use Windows, you can come here, Windows 10 and 11. If you click on properties, right? Click on properties. You'll see a screen that will show you your IP address and your MAC address. Have you seen it? Properties. No, connect. Maybe connect first to the network. Have you seen it?
Yes.
Okay, you have seen your MAC address. Okay. Go to, if you're using Wi-Fi, are you using Wi-Fi or just go to one of them, any of the network adapters. Sorry, I can't see your screen. Go back. Network and internet. Okay, properties. You scroll down now, you see your MAC address. So, yes. You can also find it in your phone. As far as it's a networking device, it must have what? An IP and a MAC address. Physical address, same thing as the MAC address. IMEI. No, that one is different. The IMEI is for the phone. The MAC address is the serial number for the network adapter. Remember, for there to be communication in any host, they need a network adapter, isn't it? The serial number for that network adapter is the MAC address. It's not showing. Have you connected to a network?
We're using the same Wi-Fi, we need different MAC addresses.
Is unique to your device. It doesn't change.
Okay.
Yes, it's a physical number, like a serial number, so it doesn't change. Even your phone has a serial number. Yeah. Yes. It doesn't change. You can click on more Wi-Fi settings. Okay, so click on this one now. Since it's Wi-Fi, you can click on it. If you scroll down, you should find it there. Okay, so I believe most of us have seen the MAC addresses. Does it have the same things we've talked about, the same properties? It's a 48-bit number, isn't it? Having each number as a base 16. Okay, now that we can identify what a MAC address looks like, now let's look at how a switch works. We've been talking about The switch. The switch looks like what? It works like an extension, isn't it? It works like an extension. But in networking, there must be a principle of how it works. So we want to look at how it works. When a frame, what's a frame? What's a frame? A data in what? Layer 2, which is in the switch, is a frame. So we have this switch here now, and a frame is going in. Once it enters the switch, the next thing that happens is that the switch would learn the what? The source mark. Once a frame is going out, it always carries out what? With it, the information. In that information, you see what? The source mark. The next information it will be holding is what? The destination mark. Then the next one, the source what? IP. And also what? The destination what? IP. These four things are what? Key for communication. So as this frame is going out, okay, we are in layer 2. So let me not talk about IP. Since IP is layer 3, we're just concerned with the MAC address. In this case, we're in layer 2. Now, the source MAC and the destination MAC, as it goes to the switch now says, okay, I have a frame with this source MAC on port 2. This is port 1, port 2, port 3, port 4. So the switch has a table, a switch table. That's what I'll call it for now. That switch table, it now says, okay, in my port 2, I have received a frame, right, with this source MAC. So that means anytime I want to communicate with that MAC address, I should be going out via port what? 2. So it holds it and maps to its table. Port 2, it will now map the MAC address that I found. 0.0, 0000, 00, 1, 1, 1, 1, 2, 2. It has received that frame. It holds the source mark in its table. Now that frame is saying, okay, please, I'm going to this destination. Are we following? Please pay attention. I'm going to what? This destination. In this case, in our switch table, we may not know the destination mark, right? So we don't know the interface to go to. What does the switch do? At this point in time, it will flood this frame to all other what? Ports. It will flood it out. It's not a broadcast message. We are not talking about broadcast yet. It's not a broadcast message. As it enters that switch, because the switch does not know where the destination port is, what does it do? It floods it out all the ports that it has. Now, at that moment, if 3, 4, 5, 6, if 6 is where that destination mark is, that is the computer connected to this port 6, holds that MAC address of the destination. This computer here would what? Give a reply, isn't it? Indicating that it has received the packet. At that moment, where this port will give that reply, the switch will now know, okay, for port 6, that destination mark is in what? Port what? 6. So what will happen the next time another computer is sending a message to that destination mark? What will happen? Straight now. It's not going to what? Flood it again. Does that make sense? Yes. I believe we have understood it already. So if the destination mark is known, it only forwards it only to what? That port. But if it's not known, it will what? Flood it to all the other ports. That's the way the switch what? Works. Okay? Ask a question.
I want to ask, what if maybe you that particular message you want to send, you intend that the switch should flood it because you want to use another port. But because that particular port has been identified with the number, it's now restricting it. Let's assume this particular port is bad. Okay? Let me just put it that way.
And you plug the cable now in another
Yes,
port.
you are plugging somewhere else.
Mm.
And you are expecting that it should flood so that you will now use another port. But because the port has been registered with this port already, how will you be able to like I don't
Change.
know, to change it?
Yeah, I get what you're saying. I get what you're saying. Okay? So, how do we change it? How do we change it? It's by when you plug your computer to the network, there are messages that go on. There are unknown messages that you are not knowing, but they are passing, right? Even your computer may be looking for a DHCP IP address, isn't it? It will send a message. That frame from your computer going out would what? Hold what? Your source MAC, which is actually the MAC address of your what? Computer. So now, in this case, we are no longer connected to port 6 again. So that means we are now connected to what? Port 4. What will happen is that the switch will receive that MAC again. And it will try and add it to its what? Table. Now, it will see that it's already holding that MAC is in port 6. What will happen? It will just update it to what? Port 4. But when we go on, and those of us that we increase in security testing, we'll find out that this is actually what? A loophole, what we call an exploit. With this now, there are some attack surfaces that you can what? Build based on this policy that ports can just dynamically what? Change.
Thank you, sir.
So is cybersecurity interesting?
Yes, sir.
Yeah. For those cybersecurity people? Ask.
Can you just introduce or just rephrase everything you just said?
Okay, I will take it again. The frame. What's the frame? A data link what? Packet. A data link data. Any message that is in what? In layer 2 is called what? A frame. If it's in layer 1, which is the physical layer, it's called what? Bits. Now, a frame is a layer 2 message. That layer 2 message enters what? A switch. There are properties that a frame would what? Hold. It's going to hold the source MAC, which is the MAC address of the sender, right? And it's going to hold what? The destination MAC, which is the address it's heading what? To. It must hold those two informations. Now, based on that, the switch would pick out the source MAC and attach it to its switch what? Table. Isn't it? Every switch has a what? A table. It picks that source MAC and attaches it what? To its switching table. Now, if the destination MAC address is not in its switching table, at that point in time, the switch will what? Take a decision. That decision is, please, I don't know where this message is intended what? For. Since I don't know, I will what? Spread it out of all the other interfaces, except from the one it was received what? From. Except from the one it was received from. So all these other ports in the switch would what? Receive that what? Message. And at that point in time, if the destination MAC, the computer that holds that MAC address is in the network, it will receive the message, isn't it? And it will indicate by giving what? A response. Once it gives that response, the switch will also, that response message would hold the source MAC of that what? Computer responding, isn't it? So the switch now will now know that, okay, this computer is on port 4. It will now attach it also to what? The switching what? Table. So the next time this other computer here sends a message to that destination MAC, it does not need to what? Flood it again. Just going to send it what? Directly. So that's the way every switch works. Now, based on this, We'll now see another table that comes up in the switch, which we call the what? The AR what? P. ARP means address resolution protocol. So the address resolution protocol is what maps the IP address to what? The MAC what? Address. So in a switch has the normal switch table that just holds the binding of the what? The MAC addresses to the ports. But when we proceed to layer 3, the layer 3 is where the IP address is, isn't it? By the time we go to layer 3 now, we'll start talking about what? The address resolution protocol. Now, you're trying to go to 192.168.10. You have the destination IP, the source IP. You have the destination MAC. As that frame enters, the ARP table will take the source what? MAC, isn't it? It will also take the source what? IP and build its ARP what? Table. So it will now hold the IP address, binding it to what? The what? MAC address. All this is just to enable what? Communication, and also to enable what? Security. Because the switch is an extension does not literally mean that anything that is coming from here, every other person should what? Listen to it. No. That's a security flaw. So the switch table and the ARP table, we are built in to mitigate what? Security. So only the messages that should flood, because there's a MAC address for what? A flooded message. That MAC address is FFF. Anything that starts with F and ends with F. Once you send a message to that, it means broadcast what? Frame. Every packet in the switch every host in the switch will receive that word? Frame. It does not have an intended destination. That's what it means. All right. So those of us with our computers, we can still use this command to find out the ARP table in our computer. When a host wants to talk to an IP address, it checks the what? The ARP cache. If no match, it sends an ARP request. Who has that IP? The host will reply with both its MAC what? Address. Remember, for the switch to forward messages, it needs what? The MAC address, first of all. Before we get to IP address, for there to be communication between two computers in a network, you need to what? Know the what? MAC address, because that's what the switch will use and forward the messages. Now, I know your IP, but I don't know your what? MAC address. What will happen? I will find a way to request what? For it. Because in the layer 2, remember layer 2 is before layer 3, isn't it? Layer 2 is before layer what? 3. We've been talking about layer 3 since. But layer 2 is before layer 3. Now, because layer 2 is before layer 3, the ARP table will try and find out who is who before it now sends the IP message, isn't it? All right. So based on that, it sends an ARP request. Who has that IP? When your computer sees it, the switch will still forward it because it does not know the destination MAC, right? When that destination MAC replies, it will add it to its switch table. Then the packet can now go. That's the IP packet now in layer 3. Can now what? Proceed and move. First of all, this communication for the switch table is in what? In layer 2. That's before layer 3. So those are just the brief explanation of how packets and frames in a network moves around. I just thought to add that, but I don't want you to be confused with it. After that, we'll head over to what? The VLAN. Is it break time?
Yes.
All right, let's go now. Let's go for break. No, let's not go for break. We started by 12:20, 10:20. 12:20, we'll go for break. 12:20, we still have 11 minutes. Let's just take this. So we've talked about the VLAN already, isn't it? We've talked about VLAN already. We'll go for a break. Don't worry. I didn't take your break time. You're going for break. We know that a LAN or a network is a grouping of two or more computers on a network, isn't it?
Yes.
We already know that.
Yes, sir.
So a virtual LAN is like a virtual LAN. That's what it looks like. It is a subgroup within what? A local network. So you have a switch and you have different subgroups, right? That's what we call what? A virtual LAN. Virtual LAN makes it easy for network administrators to separate a single switched network into what? Multiple what? Groups. Financially, look at it. You have a company that have three different departments. It has three different departments. Now, you cannot go and buy three different what? Switches, right? That would be what? Expensive. Imagine if one switch is equivalent to 1 million naira. That means three switches would be equivalent to how much? 3 million naira. Now, and out of that switch, you just need, maybe each department just need like 4 computers in them. So that means if you even buy a 24-port switch, you have not even utilized all of it, isn't it? Isn't it? So that means investing 3 million naira would be what? A waste in that scenario, isn't it? So what do? We can now use a single what? Switch and subgroup it using what? VLANs. So we can now say all the people from department 1 will connect between port 1 and port what? 6, because we will configure that to be a single VLAN. Then all the people in the second department will be from this port to what? This other port. So you now say we use VLAN for what? Traffic what? Segmentation. We segment traffic. We also use it to what? Protect what? Security. Remember, anybody in a switch can eavesdrop on what is what? Happening, because they'll be hearing the broadcast messages, isn't it? And packets always goes around in the network. So by the time you have subgroup a VLAN, it means that when you send a broadcast here, that broadcast will not go to this other port in the next VLAN. Do you understand?
Yes.
That broadcast will only be in that what? That VLAN. So that means even if we are using the same switch, but because we are not part of the same VLAN, we'll not hear each other. Does that make sense? So in essence, it actually means that we now belong to 2 different networks. So communication between us would need a what? A router in between. Are you seeing it? So it also helps us to increase what? Performance boost by reducing what we call broadcast traffic. Now, using a VLAN for your network, you can minimize each department to fit their subnet. So, for instance, a department needs 10 computers. You slim fit their IP block to just fit them, isn't it? And by doing that, the network is not too big. So that means broadcast will not be coming from here and what? There. Yeah. Broadcast traffic is also a traffic. So when we start looking at traffic performance, we'll see that by using VLAN, will increase what we call the what? Performance of the network, because we'll now say when you send a broadcast here, it's not going to flood all these other ports, isn't it? It's only these ports that are part of that same VLAN that it will flood. So we have reduced what? The performance drain, that broadcast from here will go over here, and broadcast from here going over here is not what? Good, right? It's too much broadcast here and there. So VLAN will help us segment it. So VLAN is a logical group of devices, logical, virtual, across different physical what? Locations. So that means cables can come from here, going to different places. But because they are not part of the same VLAN, they will not be hearing the same thing. That's what VLAN is. Today too, we need to we need to do all these things in practical. As we're learning, we'll do practical. So I just hope that before we go on break, we should have talked about almost everything we have for today. So as we're coming back from break, we are looking at it in practice. How many minutes more? 5. Okay, so this is just a pictorial view of what we've been talking about. So we have a switch. 1, 2, 3, 4, 5, 6, 7, 8. These 8 ports have been configured for what? VLAN 10. So that means broadcast from here would flood only these other 7 what? Ports. It won't escape and come here, right? Broadcast from here will not escape and come here. That's what it just means. But the normal operation, if there was no VLAN, it means that broadcast from here would go over here, right? If there was no VLAN, isn't it? Broadcast from here will go over here. So VLANs just help us to segment what we call the broadcast domain. We segment the broadcast domain to just here. We segment this side to just here. That's what VLAN helps us achieve. And based on that now, we'll now know what we now call the trunk and the what? The access ports. As part of VLAN, for VLANs to operate, some ports will be called what? Trunk ports. While some ports will be called what? Access ports. So in essence, trunk ports are ports that carry 2 or more VLAN. So in essence, what it means is that I have a cable from switch 1 going to switch 2. In switch 1, I have a computer that is in VLAN 10. And in switch 2, I have another computer that is in VLAN 10 also. Right? Now, I just have a single cable going from switch 1 to what? Switch 2. In switch 1 also, I have another computer in VLAN 20. And in switch 2, I have another computer in VLAN 20. And I'm still using only one cable to carry these 2 VLANs to share traffic across them. Do you understand? So that cable, because it's going to be holding the traffic of both VLAN 10 and 20, it means that it's a what? A trunk what? Cable. Do you see it? It's going to hold the information of 1 or 2 or more VLANs. It's a trunk cable. Why the access cable or the access port is actually the port going out to what? The end computers. Your computer now, you don't really care about the VLAN you are in, isn't it? You don't care. So since you don't care about the VLAN you are in, there's no need for us to bother you with VLAN what? Information, isn't it? All we just need to do is offload that your VLAN traffic to that your what? Port. Which now makes that port what? An access what? Port. This port is accessing VLAN 20. This port is accessing VLAN 10. Do you understand? So that means trunk cables will be used for switch-to-switch what? Communication. You need this switch. You have 2 switches in a loop, and you have 2 different VLANs spread across them, and you want to enable communication from here to here. They are the same network. They are not different network. Remember, VLAN is not different what? Network. So they don't need a router. We are not yet in router. It's just a switch communication. So that means this traffic needs to pass through its own VLAN and go. This other traffic needs to pass through its own VLAN and also what? Go. They will not come here and mix. They are not mixing together. They are not mixing. They are passing as different what? Pipe. What we call what? Trunk. Does that make sense? That's how VLAN what? Works. So maybe we also look at them in what? In practice. The trunk is a single cable. The trunk is a single what? Cable. But it's called a trunk because that single cable now allows the traffic of 2 or more what? VLANs inside it. On the same? No, it cannot be on the same switch now. It's interconnecting to different switch. I think we will pause here and go for break. Then after break, we'll now look at bridging and spanning tree protocol. Then I think after that, that should be where we'll start our lab from. So all these things we have done today, we'll start looking at them in what? in a lab what environment. Are we following? All right. So let's go on break. Okay. So welcome back. I hope we have cooled down. Have we cooled down? I know we are learning a lot, so that we'll do some practicals. So we have on the slide now a bridge. So a bridge is a layer 2 device that connects multiple LAN segments and forwards traffic based on MAC address. So instead of confusing you, just know that a bridge and a switch is what? The same thing. Do you understand? It's interchangeable. A bridge and a switch, same thing. Without control mechanisms, when you have multiple bridge or multiple switch in a network, we can create what we call a network what? Loop. I believe that when I explained ring topology, we remember I showed us an example of what a network loop look like, isn't it? Where a packet that is destined to go to one location, instead of arriving at the destination, it begins to go around in circles in the network. So you send a packet, and that packet finds a way back to the source. We have a switch, and we have a switch. Now, I send a message here. Okay, let me just say I'm sending. These are the cables. This one is from Eta 1 to Eta 1 here. This one is Eta 2 to Eta 2 here. Why this one is from Eta 3 to Eta 3. Now, in essence, what this means is that, yes, we have a switch, but there is a loop in the topology, isn't it? We can call it ring topology, but in essence, there's what? A loop in it, isn't it? A message heading here, can go here, right? And also what? Come back. Does that make sense? It's a loop. And if we don't mitigate such loop, it will, I'm looking for a physical scenario that loop has happened with, but I can't remember it. Let me just go on. So it means when you send a packet here, that packet will come back to the what? Sender, which is still forward it back again, right? And it still be what? Looping. So it's going to be looping indefinitely. Do you understand? So what do we do to stop that loop? Looking at this topology, what do we do to stop the loop?
What you do to stop the loop is to disconnect it from the last computer that is going back to the computer that sent it.
So we terminate this link.
Yes.
Is that correct? Do we all agree? Yes. So that means if I send a message from here, it goes here, it goes here. There's no way for it to come back to the what? To the sender. So I've stopped the what? Loop. That's the work of what? The spanning tree protocol. So with spanning tree protocol, we could enable loop communications like this and enable a ring topology. But loop will not what? Happen because of what? Spanning tree protocol. It helps disable that interface that will cause the what? The loop. That's what it's going to do. Loops are dangerous. It can cause what we call broadcast storms. In fact, once you start a loop in a network, you'll see how the network will just become noisy because in the network there are broadcast messages always going. And the worst thing that can happen is for a broadcast message to loop. If a broadcast message loop, the danger is in an exponential format. A loop between one host, right? As it broadcasts to the 24 other hosts in the network. Those 24 other hosts will join in the what? In the loop. Do you get it? So it's going to be what? An exponential noise. And before you know, normal communications now that should be happening in the network will no longer work because those broadcast storms will utilize all the traffic in the what? In the network. So we should avoid loop. It can cause what we call the MAC address what? Flapping. When I was talking about the switching table and you asked the question, it can cause MAC address what? Flap. Now, the switch, see, I thought this message was coming out from ETA 1. How is it now coming back to me through ETA what? 3? It will change the table to map it to ETA 3. Before you know it, will come back again via another port. So the MAC address table will just be what? Changing. It can cause network outage and overload of the what? CPU by congesting the whole of the network. In fact, if you had been researching recently, you find out that Cloudflare mitigated about a 7 terabit DDoS, what we call DDoS, distributed denial of what? Service. There was a host on the internet where an attacker was launching a very big surface attack on it from different, what we call it, why is it distributed? Different computers from all over in the internet. I said it in our first class when I was explaining security, why you need to secure your device. When hackers hack your device, you think that they're hacking it to change your password. No, isn't it? They use it to build a surface of a bigger what? Attack. Now, they launched a distributed denial of service attack on a single host coming from several places in the internet. Cloudflare, the client was using a Cloudflare service, so Cloudflare was able to what? Mitigate that kind of breach. So Cloudflare helped in mitigating a DDoS attack. A loop, in this case, may look like what? A DDoS what? Attack. Because as it's going to be happening, even the legitimate ports that should be working normally will stop what? Working. Because everything has been what? Used up. The whole resources have been used up by broadcast storm. I learned it the hard way. That's my own physical experience. I learned it what? The hard way. I didn't know about it, and I configured the network. And before I knew, I was plugging cables here and there. I don't know that the cable I was plugging was coming from the same what? Switch. And I plugged it to another port on the same switch. Do you see that loop there now? It's not another switch. It's just coming from the same cable and it's looping. And at the end of the day, fire. Network loop, broadcast storms happening. Before I knew, the whole network was what? Down. Now, for you to even figure out where the problem is coming at, you need to log in, isn't it? You need to access the network, isn't it? Now, in this point where you can't even access the legitimate traffic, can't even be what? Accessed. So that means you couldn't even find out the issue. Are you seeing it? So at that point in time, I started unplugging all the cables on the what? Switch. Until I found out the one that stopped the what? The storm. And I traced that cable. And at the end of the day, I found out that cable was actually a cable that was looping from another what? Port. And that was how I solved that problem. That was the hard way. But before I solved that problem, do you know that there was a network what? Downtime, isn't it? People that were using the network at that point in time wouldn't be able to what? Browse because of that broadcast what? Storm. So you should also know about it. Don't learn it the hard way.
Is it only by
No,
Is there any other way?
there are other ways now, like we just talked about now. From this device to another device to another device, then back to that device. That can cause a loop. That can cause a loop. Anything that you look at it that the packet road would lead you back to the destination, sorry, the source,
The source.
would cause a what? A loop. That's just the way it is. In layer 3, there was a flag that they introduced to mitigate loop. That flag is called TT what? L, time to leave. In layer 3, when I'm talking about layer 3, I mean the IP address, isn't it? Packets in the network layer. As you jump between routers to a router to router to router, they have a TTL what? Value. That TTL value decreases after every router. So once the packet moves from router 1 to router 2, if the starting TTL was equal to 255, here at this point, that packet will be having a TTL value of what? 254. Do you understand? So as it's looping around the network, the TTL will be what? Reducing till it gets to what? 0, where the router will now discard it. So yes, in the network layer, loops can be what? Mitigated. But even before that packet will go round and get its TTL down to 0, a lot of damage has already been done. So you still need to what? Avoid loop scenarios. That's why we need to learn the spanning tree protocol. The spanning tree protocol is a loop prevention protocol that allows multiple switches to be interconnected with what? Redundancy. That's actually why we need to loop switch, because of what? Redundancy. So for instance, in this case now, let's say, why did we do this? We did it so that in case this cable between this switch and this switch goes down, packets can reroute via here, isn't it? Isn't it?
Yeah.
In case this other connection here goes down, the packets that are destined to go here will actually reroute through what? Here. Does that make sense? So with this now, we have built a redundant what? Setup that is a little bit failed or proof, isn't it? That's why we actually do this. You'll be wondering, why do we now cause loop? We are not causing it intentionally. We're actually using it to build redundant topologies that allow for downtime, but that will not disconnect network connectivity. So how the STP works? STP elects what we call what? A root bridge. It calculates the shortest path to the root bridge from every what? Switch. So let me change this thing to S2, S1, S3. What does that mean? Switch, right? Okay. So it will look at this setup now and say, okay, let me make here my root what? Root bridge, which is the same thing as the root switch, isn't it? Aha. So from S2 to S1, what's the shortest path? Is via this cable, isn't it? Isn't it? So we can call it, let's say from the hop between every switch, we are calling it a value of 10. So that means the cost from switch 2 to switch 1, S1 to S2, will be what? 10. That will be the shortest path. But I'm moving from S2, I'm going to S1, sorry. What if I move from S2 to S3 to S1? What will be the cost? 20, very correct. S2, 10. S3, another 10, right? So that means by the time I've run like this, the cost is what? 20. So he looks at this and says, which one is the shortest path? 10, right? So that means anytime a packet from switch 2 is destined to switch 1, it always uses what? This route. Does that make sense?
Yes.
All right. Then what about from S3? Switch 3 to switch 1. Switch 1. What's the cost?
The shortest.
10. No, just the cost first. Let's look at the cost. From S3 to S1, what's the cost? 10. Then from S3 to S2, to S1. What's the cost? 20, right? 10 plus what? 10. 20, isn't it? So what's the shortest path? So this is what? So what this means is that STP will say, okay, from switch 2 to the root bridge, which is switch 1, I'll always be using this path. Do you understand? And from switch 3 to switch 1, I'll always be using what? This path. So STP will know that this path here is like redundant, isn't it? To come to switch 1 from S2 is not going to pass through here because it's no, that's a longer course. Do you understand? Yes. All right. So we've done the first step. STP will elect a root bridge. It will calculate the shortest path to the root from every switch. Then what will it do next? It will now block the redundant what? Link. So based on this our calculation now, we have seen that the redundant link is what? Here. Isn't it? Isn't it? Yes. From S2 to S1, I'm passing through here. From S3 to the root bridge, I'm passing through here. This is not in use. So that means obviously this will cause what? A loop. Excuse me. Okay, so based on these 3 steps now, we can now avoid what? Loop in the network. You can ask a question.
I wanted to know the STP electing root bridge. Can the root bridge election change?
Yeah, you can. We'll get to the slide that shows us how we select the root bridge. It's not just random. There's a way of selecting what? The root bridge. But the root bridge can what? Change. But before it will change, that switch that holds the root bridge is what? Offline first. It's not that the one that was selected the root bridge will just stay online. Another person will just come and take the root bridge. You will find out how it changes. So we have 3 port rows in STP. We have the one that is the root port, right? We have the one that is called the designated port, and we have the one that is called the what? The blocked port. So the root port is the best path to the root what? Bridge. So that means from switch 2, what's the best path to the root bridge? It's eta 1, isn't it? So that means this will be the what? The root what? Port. Then the designated port is the port that forwards the traffic to and from a LAN what? Segment. So what that means is that from switch 1 to switch 2, this port will be the what? The designated what? Port. Why on switch 2? That's the what? The root facing port. On switch 1, going to switch 2, that's the designated what? Port. In fact, just know that it's a flap. If here is the root port, here will be the what? The designated port. Just know it. So that means from S3 to S1, here will be the what? Root port. Is the port facing the root bridge. So that will be the what? The root port. Why this will be the what? So that means this port here will be what? Blocked. This will be the what? The blocked port. Because it's using that port to prevent loop. Okay? So we have different port states that STP uses to get its port rows. So we have, I'll start from the listening state. Okay, sorry, I'll start from the disabled. Either it's manually shut down or it's shut down by what? Admin. Then we'll now go to what? The learning. It learns MAC addresses, but it does not what? Forward traffic. So meaning it can hear, but it cannot what? Send. So loop can be stopped in that state. Then from that state, it will now go into what? The listening state. It prepares for forwarding, but it does not what? Learn. Then we have the last state, sorry, not the last, the forwarding state, which means the normal operation by what? By directional traffic. Or we have the blocking state, where it's listening for what we call bridge protocol data units, BPDUs, but it doesn't forward what? Frames. So these are just the port states that STP uses. I don't want to go into it in advance so that will not confuse us. We have not gotten to that level. Then based on this, we now have some versions of STP that have been developed with time. So we had the first STP, which had the name of 802.1D or legacy STP. It was slow because why was it slow? It took within 30 to 50 seconds to converge. What we mean by converge? After a topology change, maybe you have unplugged this cable or this cable has gone down, right? Before STP will reroute and packets from S1 that are headed to S3, before they will now start taking this path, it will take about how many seconds? 30 to 50 seconds. So it was slow. So that now begat what we now call the ROSTP, Rapid STP, 802.1W. This one had a faster convergence, and it was also backward compatible with STP. So let's say you have a bridge running ROSTP, and you had this other bridge switch here running STP. Their two will still what? Communicate. Backward what? This one was backward what? Compatible. Are we following? That's what it just means. Then the rapid STP had a convergence of less than 10 seconds. Because in that RSTP, they removed some of the states that are not used. Disabled and blocking, they almost did the same thing, isn't it?
Yes.
So they removed one. Out of the 5, we reduced it what? To 3. Then we went further to develop a MSTP, right? Which is multiple what? STP. 802.1S allows multiple virtual LANs to share different tree logic. That tree logic now is the same thing as STP. So it means if you have a switch that have 3 different VLANs inside it, right? In RSTP, all of them will be sharing one single STP protocol, STP3. So whether you're in VLAN 1 or VLAN 2 or VLAN 3, all of them will be using the same tree that we have just drawn, isn't it? Isn't it? But in MSTP now, there was now a chance for each VLAN to have its own type of what? STP3. So maybe in VLAN 1, the root bridge is this port. This switch. In VLAN 2, the root bridge will now be what? This other switch. So the topology will change, isn't it? This will now be the root port, right? The root bridge. So that means this port now in VLAN 2 will be the root port facing the root what? Bridge. You understand? So that was for MSTP. MSTP allowed for multiple VLANs to have their own type of STP3 to share different tree what? Logic. Then we have what we call the PVST plus and the rapid PVST plus. Cisco, these two are vendor locked towards Cisco. Cisco developed their own STP protocol. The first was the PVST plus, and the second was the rapid PVST what? Plus. In Cisco, they made sure that this STP version 1, they switched it and enabled the per VLAN STP in it. So their PVST plus, even though it was slow to converge, but each VLAN table had its own STP what? 3. Do you understand? Do you understand? This, when we are talking about networking, you start seeing that different vendors develop protocols for their own devices. Are we following? So that means if you want to enable communication using their protocol, you must buy their what? Device. Do you understand? So for instance, now we want to enable a network that uses PVST plus. We cannot go and buy a microtic device because microtic device does not have support for that protocol. We have to go and buy a Cisco what? Device. Are you following? So the PVST plus was Cisco's own modification of the STP what? Protocol to suit their own what? Devices. That's why it's Cisco what? Proprietary. Then we have the rapid PVST plus. It was the RSTP modification for what? Cisco devices. Do we follow? That's just where it says these different variants. We have standard of 3 variants: STP, RSTP, MSTP. But Cisco developed theirs. So I think based on this, now you see why they don't need the MSTP. What was the advantage of the MSTP over RSTP? It allowed for different per VLAN STP3, isn't it? But which Cisco already had from the what? From the start. So from their own STP version that took 50 seconds, 30 to 50, they already had per VLAN inside it, isn't it? So they don't need the what? MSTP. They don't need to modify MSTP because they already have it. So that means their MSTP is almost equivalent to their, okay, our MSTP in Microtik is almost equivalent to rapid PVST plus in Cisco. That's what we are building from that. So STP just helps us avoid what? Loop, which we have seen how it does it. Have we seen it? Okay, so this is a slide that just shows STP in action. So someone asked, how do we know which is the root bridge? Okay, so we get the root bridge ID based on this, based on what we call a priority value plus the MAC address of the what? The switch. Remember, the switch is a networking device, isn't it? So it also has a MAC address. So we get the bridge ID based on a priority number that we put and the MAC address. So add the priority plus the MAC address and we get that value. So for instance, I'm assuming we are using STP. STP, the normal first one, right? Now, in STP now, this bridge has a MAC address of, let's say all of them are from the same make, so they have the first 3 OUIs equal, isn't it? Then their remaining MAC address, I'll just say is AA.11. Then this one is BB.22. Then this one is CC.33. Now, what is happening? By default, when you create a bridge, all of them comes with a default priority node number. That number is at 8,000. So we'll just assume that all of them has a priority number of 8,000. So we'll now look at the formula. The lowest part, the lowest bridge ID wins the what? The root port. So the lowest bridge ID becomes the what? The root bridge, sorry. The lowest bridge ID becomes the root what? Bridge. And that bridge ID is gotten from the priority plus the what? The MAC address. So by the time we add AA and 8,000, BB and 8,000, CC and 8,000, which will hold the smallest value? Obviously, it's going to be what? AA, right? There's A before B, isn't it? So A will be the what? The smallest. So that means in our STP rule, this will be the what? The root bridge. I didn't put the other rules that may be involved, but just so you know, if the priority we consider there's precedence in how STP is being selected. The precedence is the priority is more what? Important. This is greater than, right?
Yes.
So priority is greater than the MAC address. So even if your MAC address is AA, right? But want to make switch 2 the root bridge, what do? We reduce the what? The priority. Do you understand? The precedence is what? Priority what? First. Before the what? The MAC address. So when we are looking out for the bridge, the root bridge, we're going to find out the bridge with the lowest priority what? Number, first of all. Let me revert it to 8,000. Now, if you add the topology with this, all of them have equal priority number, isn't it? Then, since there is a tie in the priority number, we now look for the what? The lowest what? MAC address. So based on that, now that's how we now found out that AA was the lowest MAC address. Remember, MAC address is what? Unique. So there will be no duplicate MAC address. So that means someone must be what? Lower. Do you get it? That one cannot tie. Someone must what? Be lower. So that's how we got AA. So that means if we want to make S2, since we already know that S1's bridge ID, MAC address is lower than S2. In an STP election, switch 1 will always win. But we want to make switch 2 to be elected the root bridge. What do we do now? We rig the election by giving him a more lower what? Priority. So based on that now, because the priority value is lower in S2, S2 is always going to win the what? STP what? Election. That's how we change. So you now see now that we can make a bridge in VLAN 10. Primary, that's the root bridge. Then in another VLAN, we'll make another bridge, the what? Root bridge. Just by changing the what? The priority number. That's how we do that. So it's simple. So this is a picture of what we just did on the board. In this case, I know it's not too clear, but this switch A, has a MAC address of AA1 with a priority value of 32,769. Switch B has a MAC address of BB1 with a priority value of 32,769. Switch C has a MAC address of CC1 with a priority of 32,769. Based on this, we know how to calculate the root bridge, isn't it? We'll first of all check out for the lowest what? Priority. And in this case, all the priority are what? Equal. So since they are equal, we'll now look out for the what? Lowest MAC address, which is obviously what? Hmm? Which is obviously what? Correct. So that means our root bridge would be what? Switch A, isn't it? So you now see the port from switch B going to switch A. That port is called what? The root port, because that's the port facing the what? The root. The port from switch C going to switch A is obviously what? The root port, because that's the port going to what? Facing the root bridge. Why on the root port, root bridge area, those are now what? Designated what? Ports. Then the port from switch B going to switch C is a designated what? Port. In fact, once you have on that formula, once you have a root port in a switch, right? Every other port in that switch will be what? A DP. You cannot have two root ports. You cannot have this port going to the switch, the root bridge, another port in that same bridge facing what? Facing the root again. No. It will block it. One of them will be what? Blocked because it's a loop. So that means every other port in that bridge will be what? A DP. Then on this other switch, that port will not be what? In the block what? State. So it will be what? Disabled. Are you saying it? It's disabled stop to stop the loop that will be happening in this what? Within this network. That's how STP helps avoid network loops. Do we like that? Do we like that? I think that brings us to the end of our class today. So based on what we have learned so far, I want to do some labs with us. Are we following? Would that be good?
Yes, sir.
It's so, I know that some of us would want to learn Cisco, but for the purpose of everybody's understanding, we'd go with an easier vendor, which in our class is what? Is microtic routers. So we'll be looking at, in all our labs, I know we downloaded the packet tracer, isn't it? We downloaded packet tracer, but packet tracer only enables you to test Cisco products. Are you following? So you can utilize that for your own increase. But for the class, we'll be using what? Microtik what? Hardwares. Now Microtik, they don't have their own virtualized platform. But their routers, you can buy it. It's cheap. You can buy a Microtik router for as low as 70,000, 50,000. But a Cisco router, you should be talking about having up to 800,000 naira in your account. All right. But there are still ways where we virtualize what? Microtik what? Routers. The only problem is that they're a little bit technical. For the Cisco, you just saw what we did now. We just downloaded the app and spin up the what? Routers. That was all. But for Microtik, you will go through the other one. What's the other one? GNS what? GNS 3. And in GNS 3 is there's a little technicality. But I think as part of the class, for those of us that will continue, it will show us how to set it up. But you can go and research how to set it up on your own. Also, you can still install the Microtik router as a what? A virtual what? Machine. Are we following? You can install it as a virtual machine. So even on top of your computer, you can have a Microtik router running on it as a what? As a virtual machine. That will enable you utilize router OS commands. Or if it's too difficult, you bring out 80,000 naira and you go to Garrison and you buy what? One. They are very cheap. It's not hard. They'll help you. Our lab today, what did you learn? What did you learn today? What did you learn? What did you learn? Let's start from, we learned sequentially how we learned them. Okay? All right? Is that all? Yes? We learned DNS now. What again? Eh? Eh? Mention them. If you don't mention them, we'll not do it. I've put that one. AR what? P. I think that covers all that we've learned. Okay, no. We have learned STP, isn't it? We've learned STP. And just before STP, what did they treat last? VLAN. So I think that's all, right? So we should do a lab on all these topics that we've learned today, right? Are we okay with that? Spelling team. So an example, this is a microtic router, right? We've seen it before now. We use it for our first lab. This is a router from Microtik. I think this gear is around 60,000. This one.
60.
Yeah, this one is around 60,000. It costs. Some enterprise can run on only this thing. Please don't, as I'm saying router, don't go and compare it with your MTN router. This thing is way, way advanced for MTN what? Router. MTN router is small. This is an enterprise what? Router. It's just that the number of CPUs inside it and the RAM is what? Small compared to those bigger what? Gear. That's just the difference. But those packages you can run in an enterprise package, enterprise router. You can also do the same thing with here. Okay, so this is a 4-port router with a USB power. So why am I using Microtik? This is why. We are all beginners, isn't it? We are all beginners. Now, if I start teaching you command line and I start teaching you GUI, which class would you like to join? What I mean by GUI, I'm showing you where to click. Click this, it will do this. Or I say, I'm teaching you another class. Type this command. It's going to do that same thing that the other person is clicking. Which one is better? Clicking, right? So that means I have what? Let's do the debate. I have GUI and I have what? CLI. Microtik is what? GUI. Cisco is what? CLI. So which one are you going to pick? Which one are you going to pick? Someone says Cisco. You want to learn Cisco? Yeah? Oh, yeah, who is speaking Microtik? Who is speaking Microtik? Only one hand. All of us. So I believe we have gotten the winner. So that's why we are teaching you what? Microtik. If you have learned Microtik and you have understood networking with Microtik, you can now go what? To what? Cisco. I'm not saying that you cannot learn networking using what? Cisco. The truth is, even if you learn networking using Cisco and you finally discover Microtik, when you want to deploy for clients, you would use what? Microtik. It's cheaper, easier to configure than what? A Cisco router. That's just the advantage. They know what they built. That's why they what? Built it. And it's a new company. When did they start? About 2000 or so. And what's the advantage of Cisco? Cisco have some, like, you see that we talked about STP. Cisco have their own proprietary what? Protocol for STP, meaning their support. They have a lot of vast knowledge in what? In networking. In fact, your certifications in networking, a Cisco certificate would hold more reputation than what? A Microtik what? Certificate. But I'm not saying their Microtik is invaluable. It's not. Do you understand? You're looking for a job now. You're looking for a networking job, and you have a microtic certificate. And another person is looking for a job, that same job with you, and that person have a Cisco what? Certificate. In the global space, they would prefer the person that has what? Cisco. That's the name. They have a global what? Name. But it's not that the person that has the microtic certificate does not know networking. In fact, even in practice now, the person that has microtic can even be better than Cisco because it's not hard to learn. So that means your learning curve is not too high. That means you can assimilate what? A lot of network concepts better and faster than someone that is learning what? Cisco. Do you understand? But if have grown, you have advanced, it's good. You know how to use Cisco. You know how to use what? Microtik. So anyone, as you go out to a feed, anyone you face, you what? You write the language. You speak the language. Is it good that you know how to speak Hausa, you know how to speak Igbo, and you know how to speak Yoruba? Is it a good thing? It's a good thing. So anywhere you find yourself, you are fluent. Do you understand? You'll not be looking for a translator. Does that make sense? Okay, so for the class, we're using the microtik class router. So we'll look at how we build a switch, how we do a VLAN, how we do DNS, DHCP, ARP, STP, and even the previous class, which I think it was even part of this class, the static and the what, DHCP, how we put addresses in what, in the router. Then our next class, we'll be talking about wireless technologies, Wi-Fi. So our next class will be talking about Wi-Fi and the routing. Our next class is routing. We all know that one first, isn't it? Well, as part of add-on packages, we have Wi-Fi for next class. So by next class, we know how to configure Wi-Fi's. All right, so let's go. Because Microtik is GUI, that means they developed a graphic user interface software. And that software is called what? Winbox. You can still configure Microtik routers or switches from your web browsers. You can still configure them from web browsers. You can still configure them from command line, even using Secure Shell, SSH, using Telnet. And you can still configure them using APIs and so on. So it's just about simplicity. For simplicity, which one are we going to go with? The what? The GUI, the graphic user interface, isn't it? So that we'll all see everything. So okay, so let me download the graphic, the Winbox, isn't it? So you can just search a Google search, Winbox. So I can see that in microtik.com. Is Islam working? Okay, so on the website, can you see Winbox here? Can we see the screen?
Yes.
So I have 3.42 and the one that is in beta version 4.0. Beta is testing, so I don't want to test. I need a stable version. I download the Winbox 3.42. My computer is a 64-bit computer, so I download that one. Please, Choma, do you have other router, any other spare router? Check if you find any other one. Let's just wait for it for how it finish.
say go, we go. You say come, we come. So they started making posts now that we have started to no laptop, so we'll hear your views.
Okay, it's done. I want someone from the back to take this. You come forward. Take this. LAN cable. Yeah, sorry. You didn't bring for me, oh. Get LAN cable from those to happen. Okay, so we have downloaded the software. We will connect. We'll open it up. Are we following? Run. All right. So this is the default screen of the Winbox what? Software. So if you look closely, you'll see a tab here, manage and what? Neighbors. Are we following? The neighbors shows us the microtic devices that can be found in our network. Those are what? Neighbors. Why the managed is a table that shows us the saved login what? Information. Are you following? Then we'll now go up. The connect to stands for what? The IP address or the MAC address of the device you want to what? Connect what? To. Are you following? Then the login information, the username and the what? The password. Okay? So currently now, my computer is not yet connected to any microtic device, isn't it? So that's why I can't see anyone in my neighbors. My neighbors is what? Empty. But at the point where we have connected a machine, a microtic device to our network, we should find that in our neighbors. Please, can you bring that router for me? Okay? Okay. So I have connected mine to a device. It has not come up yet. You can refresh. Can be refreshing until it comes up. Can we see it there? Make it full screen. Let me zoom in so that we'll see. I think it's more visible now. Come on, carry, come on, carry. Oh, no. So in the neighbors tab, we can see the MAC address of that of the router, isn't it? Now, in networking device, each in a router, in a switch, each port has a unique MAC address. Are we following? Can we see the MAC address for the port I'm connected to, ETA1? Can we see it? 7898 1834 382. Now watch. I'll connect to the next port, ETA2. And I will what? Refresh. Do you see the difference? Do you see the difference? The former one was what? 3826. Now is what? 27. I'll go again. I'll connect to the what? To the next one. Are you seeing it? 38 what? 28. So that means the last one is obviously going to be 3829. It has 4 Ethernet interfaces. And this is also a wireless router. It has a Wi-Fi inside it. So that means the Wi-Fi should also have a MAC address. The wireless adapter should also have a MAC address, which that one will be 3 what? 3830. Are we following? So you see that MAC address is what? Unique. Anybody that connects to this port would always find this what? MAC address, because that's the source MAC that will be coming out from that packet. Sorry, from that frame. All right? Then the next information I want to get from the neighbors column is what? The IP address. Something funny happened. The first time when we loaded it, it was showing 0.0.0, isn't it? And when I changed the port to ETA2, I can now see that the router is on, the IP address of the router is 88.1. Do you see that? If you don't see it, while I was on ETA2, 88.1. I was on ETA3, it was still showing me 88.1. If I move to ETA4, I am certain that I will still find the same IP of what? 88.1. Okay. Because I turned it on to work again. Sorry, I don't know what's wrong with this cable. Okay. Okay, I think 3829 is the last one, right?
Yes.
Eta 4. So, do we still find that IP address? 88 dot what? All right, I'll now go back and connect to the first port that we connected to. Come up now. Why are you delaying? Okay, 27. Okay, I'll wait for it to come up, but let me explain what I want to explain with it. So, we noticed something. We have 4 Ethernet ports, isn't it? 1, 2, 3, 4, isn't it? And from ETA 2, 3, and 4, we got the same IP information, isn't it? 192.168.88.1. What this means is that these 3 ports must have been what? Bridged what? Together. So that means anything here, anything here, anything here, they all belong to one single what? Network, isn't it? That's why they're all sharing the same IP information. I don't know why I don't want to come out again. Um, okay. I think I know why. I know why. There may be a firewall block on it that is not allowing it to advertise the information concerning that device on the ETA 1. But if I'm on ETA 2 and I'm on ETA 3, I'm on ETA 4, it can advertise who it is. Do you understand? So you can actually block what we call neighbor discovery. These neighbors we are seeing here uses the neighbor discovery what? Protocol. So you join a network, there are devices in the network that are actually issuing out their neighborship. So you can easily what? Know. So you can easily find out their IP address or find out their what? Their MAC address. So let's just go from the end that is not firewalling us, that is not blocking us to know who it is. So that we can now configure what? The router. Okay, the next thing is the what? Identity tab. In MikroTik, or even in Cisco products, we have what we call the what? Identity. In Cisco, it's called host name. Now, you use that to what? Name this what? Device. So maybe this device is the router that you are using to power this classroom. You now name it the router that powers what? This classroom. So that anywhere in the network and you see that device, you can know where that device is. Do you understand? Then we have the version tab that holds the software information of that router, the board name, the system model number, and the uptime. How long has it been powered on? Okay? So in this case, we want to build a connection to this router. In Winbox, we have two methods of connectivity. You can connect to a device using its MAC address, or you can connect to the device using its IP address. For your MiFis, you always use IP address, isn't it? And that IP address goes to a web page, isn't it? Aha. In Microtik, you can still use the IP address and connect to it via Winbox. So watch the screen. If I tap on the IP address, this is what populates there on the connect to. What am I now trying to build connection to? The what? IP address. If I tap on the MAC address, this is what populates there. So this gives us two information. You can see the IP address of a router, but you may not belong to that network. Because this one, on the neighbor discovery, is already announcing it, that this is my IP. But your computer may not be connected to or configured on that network. So there may be no IP connectivity. Do you understand that? Remember, in a network, you want to communicate. All of you have to be in the same IP network, in the same subnet, isn't it? Where all of you are sharing the same network address. So if your computer and that router are not communicating, even if you are seeing the IP address here, by the time you try to connect to it, it will fail. Because first of all, there is no IP connectivity. So Microtik made it possible to use the MAC address to also communicate with the device. Where do you find the MAC address? Direct connection, isn't it? Once you're on the same switch, your source MAC is coming out already, isn't it? So you only can connect to a router that you have direct layer 2 connectivity with the same switch. So that means if there's a router in between you cannot connect to that router again via MAC address. That's you're in different switch. You can no longer build connection. In that case, now you need IP connectivity. I hope you're understanding it. We can use IP connectivity even if we are the same network, or we are in different network, or we can use MAC address only when we are in the same network. All right. So in this case, I believe the router is running the default configuration. So that means on port 2, 3, and 4, there's actually a DHCP server that issues IP address dynamically. So my computer connecting to that port now already has an IP address from that network. You can verify from your command prompt IP config. Okay? Can we see it there? Ethernet adapter, Ethernet. I have an IPv4 address, isn't it? 192.168.88.254. The subnet mask 255.255.255.0, which is a /24, isn't it? The default gateway, which is the router, is 88.1. The DHCP has already given me all those information. So that means I have IP connectivity with this router. I can ping it. Ping 192.168. I don't know what's wrong with this. IP. Is it responding? Is it responding? So that means we can go ahead and build our connection. Okay. The password, you'll find it under the device. So those of us there using the router, check under the device. You see the password. The username is admin. For me, I have the password. Um, I'll, okay. Once you are done, you can what? Connect. Okay. So this is a program that runs every first time you buy a device and you connect to it. It's asking you all those configuration that is on it. Should it keep it or do you want to remove it? Are we seeing it? Like example, there was a configuration that enabled the IP address on it, isn't it? There's a configuration that enabled the DHCP server, right? If we decide to remove it, that means at this point in time, we will now drop all IP connectivity because we have deleted the configurations on it. And I believe we want to do that because we are starting afresh, isn't it? So you normally do remove it. So I'll remove. Um, it's asking me to change password. Let me change the password. Okay, the connection has been dropped. Now, do you not see your neighbors? Before it was showing 88.1. What is it showing now? 0.0.0. And in fact, that port that didn't allow me to see it before on neighbors, ETA 1. I'll plug to it now. And I will try and refresh. Are you seeing it there? Is it coming up now? Because that firewall rule that was blocking it has also been what? Deleted. Do you see it? So you can advertise and you can also block the advertisement. All right. I'll build connection again to the router. Now this time around, I'm connecting via what? MAC address. Now, look at the MAC address I'm connecting to. I'm connecting to what? 38.27, which was actually the MAC address in the previous port, ETA 2. But now I'm on what? ETA 1. And at this point in time, there's no configuration on it, meaning no port is bridged together. So we're not even on the same switch. So we can't even build the connectivity. So I need to cancel this and connect to the right port, isn't it? The right MAC address, which is what? 26. Okay. Wrong username or password. All right. Tick is now empty. What happened? All right. It's now empty. It's asking me to change password again. I don't want to change it. Don't worry. Cancel. And we have successfully built connection to the router. I'm waiting for demo. Okay. At this screen, we have some menus we will be interested in. As we go along the class, we'll start working with them. So today, our class and our lab today, we want to see a switch, isn't it? You're interested in seeing how to configure a switch. For instance, we connected to the router before. The default configuration, it bridged 2, 3, and 4 together, isn't it? So we want to see how we can also do that. And if you go through this menu, we have switch and bridge. But because what we are doing is bridging. What we are doing is what? Bridging. Switch is actually a physical device. Now, if you're using the switch menu, you actually want to change how the physical device itself operates. That's the switch menu. So anytime you're talking about switch, you want to join 2 or more ports together. You want to make them behave like an extension. You're always talking about what? Bridge. In MikroTik. Do you understand? Do we understand? Yes. In MikroTik, you want to bridge some ports. You want to switch some ports together. You're going to do it in the bridge menu. Are you following? Yes. And because we are talking about bridge or switch, STP is also involved, isn't it? We'll look at STP. Are we following? Then I think that's the last. Okay. Then when we're done with STP, we'll now come over to VLAN. All right. Have you built connection? Ask a question.
It's not a question.
Okay, you have the MikroTik app in your phone. Yeah. It's the same thing.
When we did it, I tried to log in again.
Have you removed the configuration?
Yes.
The new password now will be empty. There's no password again. So connect. Off your Wi-Fi. No, remember you're using LAN. Off your Wi-Fi. Just put yours. Off it. Refresh again. Refresh. So connect. The new password is empty. To ask you to change, don't change. Yeah, don't change. You can change it if you want, but just remember anything you've set. So I'm heading to the bridge menu. All right. So in the bridge menu, we have other sub-menus, isn't it? We have the bridge first. We have the bridge sub-menu. We have the port sub-menu. We have some other informations that we can look at. So first of all, you look at this table. Is it empty? It's empty, right? So it means that in this router that we are connected to, there's no bridge. Now, because we want to bridge ETA 2, ETA 3, and ETA 4, that means we need to create a bridge, isn't it? We need to create a bridge. Now, it's empty. We need to create a bridge. Where do you create a bridge? See there, shining forth. The plus button. Can you see the plus button? So I click on the plus button. It asks me, what's the name of the bridge I want to create. Then the next menu talks about the spanning tree protocol mode. So you don't want any STP on it. So that means if there's a loop in the bridge, STP will not block it. Or you want to use the first version of STP that takes 30 seconds or to 50 seconds to converge. Or you want to use rapid STP that takes 10 seconds to converge. Or you want to use MSTP that uses per VLAN STP, isn't it? So normally, if you're not talking about per VLAN STP, we want to use the rapid STP. So even if you did not come to this menu, by default, RSTP is what? Selected. Do you understand? Even if it not come here, by default, RSTP is selected for you. Then the next one we talk about is the what? The priority what? Number. Do you see that? The priority number. In Microtic, you write it down as what? Hex value. So 8,000. So that means as you're creating bridges, you're configuring different Microtic routers. All of them will be having a bridge priority number of what? 8,000. So if you want to even do the STP calculation by yourself, you find out the priority number, then also you find out the MAC address that will be assigned to that bridge. When we create the bridge, it's going to have a what? A MAC address after we create it. So let's do that. I don't want to change the name. I don't want to change anything there. I just click on OK. Now, do you see a MAC address? Are you seeing the MAC address? I didn't do anything, no. I just clicked on plus and OK. That's all. It created a bridge named what? Bridge what? 1. That bridge has a MAC address of what? B209E5018E6C. Now, if after we have built our connection, we connect this bridge to another bridge, maybe in another switch somewhere, right? After we have built that connection, STP will look at the lowest what? MAC address. I hope you all remember that. It will look at the lowest what? MAC address, because by default, once you click plus and OK, the priority number is what? 8,000. So all of them will be having the same priority number. So we need to compare what? The MAC address. I think maybe as we go along the class, we'll try and build connection to each other so that we'll see who will be elected the root bridge. Then the protocol mode. Can we see the protocol mode also? The RSTP protocol. Then the next thing now that we are concerned with, we have created the bridge. Now, how do we tell the ports that you are part of that bridge that we have created? It's by going to the ports what? Sub menu. On the port sub menu, you see it's empty also, right? There's no one-to-one mapping of a port to any bridge. So you can create yours. Sorry. In my case, now I want to create the interface. The first one is what? Ether 2, isn't it? Ethernet interface 2. We want to assign it to the bridge 1 that we have created, isn't it? Okay. And that does that. We want to create for bridge 3 also, isn't it? So we can create for bridge 3. Ether 3. Ether 3, we're also adding to bridge what? 1. All right. Then we have Ether 4. We are also adding it to bridge what? 1. Okay. And that's all. Do you see the STP rule is what? Disabled port. If you go through the slide, you'll find that we have the disabled port row. So we have added the what? The 3 ports. It's in the disabled port row because if you look at this, there's no cable currently connected to Ether 2, Ether 3, Ether 4. So those ports are not in use. They're disabled. So STP should also what? Disable it. Nothing should be going out from there. With this, we have created a what? In this our router, we have bridged these 3 ports as what? 1. Does that make sense? So it means now that if we come to our interface menu, we should see a new interface apart from the default one that are fixed to the router. The default one that are fixed to the router, it comes with Ether 1, Ether 2, Ether 3, Ether 4, and the Wi-Fi interface. That's all. But now we've created our own virtual interface, which is called a bridge, right? Which is involved in bridging the eta 2, eta 3, and what? Eta 4. Are we seeing the way we are interpreting the configuration? Does it make sense? Now, that means if we have anything to do as a configuration that should affect any of these interfaces here, who should we address? We have any configuration else. We have another configuration I want to do. And that configuration will be affecting any of these interfaces in this bridge. Who should we be addressing that configuration to? To the bridge. That's very what? Correct. So in this case, the bridge becomes the what? The master interface, isn't it? Because anything I do on the bridge would affect eta 2, it will affect eta 3, it will affect eta what? 4. Remember, they are now in an what? Extension. If you power off the main line, all of them will what? Go off. So anything you're doing, you should not be doing it on the what? On the master. Does that make sense? Okay. So I believe with this, you can now create bridges in your router. Can you? Can you? It's simple. You go to the bridge menu. You go to the bridge menu. You create the bridge. You create the bridge you want to create in the bridge submenu. You create a bridge. So we can even have more than one bridge in a router. I can create another bridge, call it bridge 2. And I say OK. And I come to ports. And I assign eta 1. And assign eta 1 to bridge what? Bridge 2. And I click on OK. Do we see that? Yes. Now, you cannot assign an interface to more than one bridge. Does that make sense? It's a one-to-one map. This port cannot be connected to this master and another what? Master. You cannot serve two gods, just one. So that's bridge. Then after bridge, I said we'll look at what? The VLAN, isn't it? In MikroTik, to create a VLAN, you just go to interface and what? VLAN. You go to interface and you go to what? VLAN. So let me write it down. You go to interface, then you go to the VLAN menu. Now we can see we don't have any virtual LAN in our router, isn't it? Now, before you create a virtual LAN, there are two things you need to look at. You need to look at which of the interface do you want to create that virtual LAN on top. Do you understand? It's a virtual LAN, right? What will be the what? The master. So where is that virtual LAN riding on? So we can say on our eta 1, we can have two virtual LANs coming out from it. Does that make sense? Like in the picture that we looked at in the slide, that one had 3 VLANs, isn't it? That was passing through the trunk, right? Or you can even do that. You can create 3 VLANs. And all of them are riding on top of what? The eta what? 1. Then the next thing we look at is what? The VLAN ID, the identifier. So when we come to VLAN and we click on add, we may not really care about the name of the VLAN, but it's good you identify them properly. So let's say the first one is VLAN 10. The next thing I look at is the what? The VLAN ID. I say two things, right? The ID and the what? the master interface. So the ID, since it's VLAN 10, the VLAN number is just what? 10. Oh God. This keyboard is hanging. The VLAN ID is 10. And the master interface is what? ETA 1. And I click on OK. That's that. I've created what? A VLAN. It's as simple as that. I want for VLAN 20, right? I do the same thing. VLAN 20. 20. And you select the word, the master interface. I want for VLAN 30. I believe that's all. Then we can come back to our interface submenu that shows us the list of all the interface. Now, something interesting is visible. You can see VLAN 20, VLAN 30, and VLAN 10. They all look like they are under who? So that just tells us that ETA 1 is the what? The master. It's as simple as what? That. Now, do you see how easy it is to see these things because they are graphically what? Presented to us. If it was command line, you have to issue out the command to list what? All the interfaces. Do you understand? So you see why we would always prefer to teach the graphical first. When you have understood this, you can now go into the advanced course, which now show you how to use them in what? In command line. So we've done two things. We've created a switch, right? We've created a VLAN, 3 different VLANs, and we have assigned them under what? ETA 1. So what this means is that if our router was to be connected to, let's say, another router, and this port is going into the ETA 1, and we now say the people connected to ETA 2, we want them to be access of VLAN 10. The people connected to ETA 3 want them to access VLAN what? 20. And the people connected to the last port want them to access VLAN 30. So what does that make this port? A what? A trunk. So this is now what? Trunking. It's trunking the traffic for VLAN 10, VLAN 20, and VLAN what? 30. All of them passing through the same what? Cable. While ETA 2 here will now be what? Access. Isn't it? Because now, this VLAN that was coming through the trunk is now accessed via what? Just that port. This VLAN coming from here will be accessed via what? This other port. So at the end of the day, even if one cable is bringing the network to this building, the people here cannot hear what's happening what? Here. We all get that. The people in ETA 3 cannot hear what's happening in what? ETA 4. Because they all belong to what? Different networks. You see how we have logically divided the networks again. So even if we have just one cable, you can carry the traffic for different companies. Now, this now explains what I told us in our first class, where in the NYSC camp, right, we had a microwave that was connected to the city, isn't it? That was connected to the city's microwave, And in the camp, all of us were able to access MTN for the people that are using MTN. For the people that are using what? Glo. And for the people that are using what? Airtel. Does it make sense now? Just that my Wi-Fi or that wireless interface was carrying the VLANs of these different service what? Providers. Are you seeing networking in action? Does it make sense now? All right, I think we can proceed. The next topic we have to treat is what? STP, right? And I've showed us a brief on STP already, but let's just look at it again. To get the STP information of a bridge, you go to bridge, the bridge menu, and you click on the bridge that you're interested in. So let's look at bridge 1, for instance. You could go to the status tab. The what? Status tab. So we can see some information of that bridge, the last downtime, the last uptime, the root bridge is checked, right? So that means that this bridge is actually what? The root bridge. Already, there's no other bridge in the network. There's no other bridge. So that means that bridge is actually the root bridge. Someone will say, but we have two bridges here. Please, they are different. They are different, isn't it? This bridge, the first bridge, bridge 234, right? One network. The second bridge is what? One. Another different side. So that means this guy can be the root bridge for this bridge, and this other one cannot be the root bridge. Maybe there's another root bridge before it. Does that make sense? So this check mark here is showing us that this bridge we are opening that bridge 1 is actually the root what? Bridge. And we see the root bridge ID. This is OX 8000 and the what? The MAC address. This is. Then we have some other information that we can look at. Then how many ports are in the bridge? 3. How many of them are designated? 0. Because none of them are up yet. If we look at the information for the other bridge, bridge 2 is also the root bridge because no other connection is made yet. You can see the MAC address also. This is the MAC address used to build that bridge. The priority ID, the number of ports on it, and the designated what? Port. You remember, from the root bridge, everything going out of it is what? DP, right? But on another switch facing a root bridge, anything facing that root bridge will become the what? RP, right? The root port. Don't forget, though. Okay, I think that explains what STP. Maybe as we go along, maybe other labs when we will now have multiple routers connected together, we'll actually see other switches and how they look like. I'll not compare it. Do you understand? So I will just hold on here. Let's do other ones. Maybe in our other labs, we'll look at STP in more details. The next topic we have to talk about is still in layer 2. Okay, it's no longer in layer 2. We're now in layer 3. Is what? The IP what? Addressing. Where we have static or what? DHCP. Please, who can tell me the menu? Just look at the screen. We're talking about IP now. Where do we go to? IP, right? Do we go to IPv6? We're not configuring IPv6. So that means the first one will be what? IPv4. Okay? So it's a sub-menu. That's some other things. We have ARP, addresses, DHCP client, DHCP relay, DHCP server, DNS, firewall, hotspot, and so on. In this case, we want to set up what? An IP address, right? We want to configure the router to have an IP address. We're almost doing like the same default configuration that was on the router, but I'm just walking us through one after the other. So I think based on that, we should go to IP addresses, isn't it? All right. As you can see, is what? Blank. No IP address. When we connected to the router previously, we saw an IP block of 192.168.88.1, which is slash what? 24. So we should try and replicate that. So to create a new address, you go on the plus button and you put in what? The address. So in our case, 192.168.88.1 slash what? I don't know why I feel like I should say it. We have two different networks. Network A and network B. And we have a router in between them, router 1. Can we see this topology? And I said the router in between these two networks is responsible for communication between two different networks, isn't it? Yes. So if a computer here wanted to communicate with a computer here, it will go through what? The router. We all understand that, right? Okay. Now, the thing I want to say is that the IP address of the router must also be inside what? The network. So on the router, this port facing here must have an IP within the same network block so that the devices in this network can communicate with what? With the router without needing another router. Do you understand? Then when they communicate with the router, because they want to go outside to another router, the router knows how to what? Route the packet towards the outside network is also going to. Same thing also in this other side of the network. The computers here would have a normal local communication between what? The router. So that means on this port facing this side, the router will be having an IP address within their own network also. So that means this router now will be having two different IP addresses. One for the eta A and another one for the eta what? B. Does that make sense? Does that make sense? So in the router also, we have configured the IP address and we have put the subnet mask, isn't it? And we come here, we select the interface. We're doing it for the bridge, isn't it? The bridge is the master, so that both 2, 3, 4, they all be part of the same network. So we're not going to apply this on eta 2, neither eta 3 nor eta 4. We're going to do it on the what? On the bridge, which is bridge 1. And we'll apply that. Now, something interesting happens. I didn't fill up the network address. Did I? No. But it filled it up, right? How do you think it got that information? It got it based on the what? The IP address and the what? Subnet mask. It found out that, okay, 88.1, obviously, and it's a /24. The network address will be what? 88.0. That's how I filled it up. Okay. All right, I want to do something. New inbox. Because I'm still connected to eta 1. Eta 1 belongs to a different switch, isn't it? We have not put any IP address on that side, right? So it's still showing us 0.0.0. Okay, let's change it now. to eta 2 and whatever coming and I refresh. Can we see it now? It's 8 or what? 1. I want to test us. I try to communicate with this router via IP address. At this point in time, do I have IP communication? For the yes, let's raise our hand. For the no, let's raise our hand. No. Because you joined the moving train does not mean you're going to the right location. In this case, we don't have IP what? Connectivity. Remember, the first time we did that, there was a DHCP server configuration on the router that automatically configured our laptop to belong to the same network. If you doubt it, you can look at it from your command prompt. IP config. Can you see it there? What do I have? I still have an auto configuration IPv4 address. When we talked about IP addresses, you remember this class? Special addresses, isn't it? 169.254.109 with a subnet mask of 255.255. Was that what we configured? Huh? No. That was not what we configured. So I've used this to show now that, yes, we can see the IP address of the router, but we don't yet have what? IP connectivity. Does that make sense? So to have IP connectivity, you must make sure that you have an IP address. And either you are going to set that address manually, isn't it? Or you have to, there must be a what? A DHCP server that will lease you the what? The IP. It's connected. We have done the IP on the router. No, the auto configuration. No, that one was already set by the manufacturers. So that one was already set. This time around, we are doing the configurations one after the other. So at this point in time, the only thing we have done is that we have said on this router, under your bridge 1 that has 2, 3, and 4, your IP address is what? 192.168.88 or what? 1. Now, if we want to enable IP connectivity between our computer and the router, we now have to what? Go to our computer settings and manually set 88.2 on our what? Laptop. Do you understand? Does that make more sense now? Or we now go back to the router and configure a DHCP server so that anybody that connects to ETA 2 and 3 and 4, our DHCP server in the router will automatically give them an IP address. So I don't want to go with the laptop on. Let's go back to the router. Since we don't have IP connectivity yet, I'm not going to use IP address to connect. I'm still going to be using the what? The MAC address to connect to it. I don't want to change. Okay? We're back here. We have our IP address set. Now, if you've been looking at the screen, you also notice that the DHCP server also sends out the IP address of the what? The DNS server, isn't it? When it's configuring the IP address of the devices, it gives them out, isn't it? It shows them, it gives them their IP address that they will use. It gives them the subnet, right? It gives them the gateway, isn't it? It gives them the what? The DNS. That's why when you connect to a Wi-Fi, you don't need to do anything. All you need to do is just put the password. The DHCP server will just give you all these things you need. So that means if we want to configure a router, we must actually impute all these things as part of what the DHCP would give out. So the next thing now, we've done the IP address facing the end host, that's the network. The subnet is there, isn't it? /24. The gateway, obviously, when we create the DHCP server, this will be the gateway because this is the IP address of the router. But we have not done the what? DNS. And if you look at the IP menu again, you'll find DNS there. IP. Can you see DNS? So it's simple. You go to DNS. On the server, you put in the IP address of the DNS server. And if you've been going along with the class, I think you should know one by now. 8.8.8.8. Owned by who? Google. Then we have another simple one. 1.1.1.1. Who owns this one? Cloud what? Cloudflare. So it's simple. You just come to the server. You put the IP address. 8.8.8.8. You want to add another one, you click this down menu. Add a new value. Click on it. 1.1.1.1. Do you see the two IP addresses? So it automatically means that when we create a DHCP server, it's going to tell our end host that this is their DNS server. All right, I think we are done with DNS. Let's close that. We have created the IP address. You can close that. So now I want to create the DHCP server. What is responsible for the automatic configurations of IP. And you find that in IP. Can you see it there? DHCP server. Now there is what we call a wizard. There is a wizard, a DHCP setup wizard. It looks like a button. It's not a menu. These are sub-menus. It just looks like a button. Before you use this wizard, two things you should have done. You should have, first of all, set the IP address on the router. And lastly, you should have done what? Done the DNS. In setting the IP address in MikroTik, you already know that you set the subnet, isn't it? By adding the slash. So those two things, once you have done it, you can now come to this wizard in the DHCP submenu. You click on the DHCP setup wizard. You select it. It's asking you, which interface should I run this DHCP server on? In our case, which one? The master interface. So that as we run it on the master interface, it will affect both ETA 2, it will affect ETA 3, it will also affect ETA 4. So we're going to select the master interface, which is bridge 1, right? Bridge 1. All right, I click on next. This is what happened. It looked in the router and found out that on bridge 1, I've already configured an IP address. And that IP address belongs to the 88.0 network, /24. Did you key it in? No. It's the wizard that went and found it. So you see why you need to set it. If you don't set it, at this point, it will not find anything. I click on next. The gateway for the DHCP network, what's the gateway again? The IP address of the router in that network, which in this case will be the IP address of the bridge interface, isn't it? Is it the .1 that we set? Yes. Click on next again. Then this one is saying the addresses it will give out. Sorry. So we can see that it's going to give out an IP address from 88.2, and it will stop at what? 88.254, which is actually the usable host range, isn't it? Apart from .1, which we have already taken for the router. From .2 to what? .254. Do you see it? Did it fill it in? No. It got that information from the what? The IP address also. You click on next again. Now, I seen the magic again. It has gone, it's asking us what is the DNS server I should use. It has gone again. You also found that we have put some IP address for the DNS, and it has what? Put it what? Here. So that means we literally don't need to do anything again. We click on what? Next. Then the last one should be the lease what? Time. What's the lease time again? How long they are renting the IP. You remember, when you connect to a DCP network, it's not a permanent IP. So you are what? You are leasing it. So it's here we now put how long that IP should be what? Valid from or leased for. So the 10 minutes is also okay. You click on next and it's done. And it says DHCP setup has completed what? Successfully. So now we can now see in the DHCP we have one server there. Can we see it? Now, I think at this junction now, my computer is connected to ETA 2. So that means I should be able to obtain an IP address automatically from the router now. So let's go and check if it has done that. Okay, it has not. So we can just refresh the connection. Disconnect and connect. It hasn't though. Okay. It's done now. Is it done? Can you see it? It's giving us an IP from the 88 pool that we created, isn't it? All right, so let's come back to our router. I believe it's clear as we are doing them, one after the other. Eh? Hey, don't worry, you have time for group work. Just pay attention as we're doing it. So we have a sub-menu called what? Leases. Can you see that? We have a sub-menu called, that means it should show us the people that have used our network, right? Now I can see one there. Is it the same thing with the IP address I saw? Yes, 88.254. And that's the name of my computer there. And it's connected via which bridge port? ETA 2. And it expires in 10 minutes. What happens is that if I'm still on the network, my computer will request for a what? A renewal. To now add another what? 10 minutes again. It's not that it will just delete my IP. As far as you're still on the network, you'll still be holding that what? IP until you are what? Gone. So if someone else brings his computer now and connect to that place, we should see it populate here after the person has obtained an IP address. Does that make sense? So we've tackled the next one, which is what? DHCP. But in this case, we actually did DHCP server. In our other labs, we'll look at DHCP client. What if this router that we are configuring wants to receive an IP address from another DHCP what? Server? At that point in time, this router will not be acting as a what? A DHCP client, right? You'll find that one also in the IP menu. IP DHCP client. Can you see there? That's where you do that configuration. The next one We're looking at the what? The AR what? P. We've done DNS, right? We've done DHCP. We've done STP. We've done static and static IP address. Aha. So for the ARP, what's ARP again? Address resolution what? Protocol. It helps map an IP address to a MAC address, isn't it? All right. And you find that in IP ARP. And I can see one already. Right? That's for my computer also. The IP address of 88.254 and the MAC address. This table they build is building what? Interested flag D. It means it's dynamic. It was automatically what? Obtained. I think at this place we can call it what? A day. Have we done enough? Have we done enough? I know it's looking new and we are not also practicing it. So you may forget. You may forget. Um, our next class, I will make sure that I'll try my best to make sure that we have more routers in the class, so that we will now do it as what? Group. Do you understand? So we'll work in groups, and we'll start doing this what? Configuration. So start expecting your group pairing, because from the next class, once I pair you to the group, that's how you will now be sitting down. Oh. All right. No.